I hope you can see all my images. For the people that are attending, if you have any questions you cannot hear or you cannot see the screen, you can post your comments in the chat. We have a packed agenda, but if you have any questions, better that you can use the question and answer module, okay, that you can see in your screen, so you can post questions and the different people that will present the projects will try to answer as best as possible, okay? And of course, we also have some poll during the workshop, so if you can't answer it, it could be great. So as I said before, the welcome to this European Robotics and Artificial Intelligence workshop applied to spatial maintenance. This workshop is organized by the piloting project, which is a project that we are coordinating from FADACATEC. And also it's organized by RIMA. RIMA is the digital innovation, the robotics digital innovation hub related to applied to inspection and maintenance. So it has a lot of relation with this workshop and all the projects. As well, at the end of the workshop, they will also have a slot in promoting robotics in inspection and maintenance application. They also have a slot. So if you stay until the end, you can see also a slot about RIMA project, which is a very interesting digital innovation hub. And of course, this also was supported by Robotics, especially I would like to thank the Area Robotics Topic Group and also the Inspection Maintenance Topic Group that helped to promote this workshop. Okay, as if you don't know what is robotics, you can go to this website, but Robotics is the most important robotics association at the European level. They represent both university, research centers, and industry. And they organize a couple of big events every year, including the European Robotics Forum. So let's start with the workshop. So we have the agenda, okay. Okay. In this agenda, you can see that we have an important number of workshops, more than, I would say 15. We have 4, 5, 15 projects. So you can see that inspection and maintenance, they has a very, and all of them are active. We didn't consider past project. Actually, yesterday I received an email from another project that we couldn't localize. So there are a large number of projects related to inspection and maintenance, applying robotics and artificial intelligence. Okay, these are all projects that apply both things. They apply robotics and artificial intelligence. Okay, there are other number of projects and maybe they are more focused only on artificial intelligence. Okay, more on the prediction part, like that. We wanted to focus on projects that also have this interaction with the real environment with the robotic vehicles, okay? And we have organized a session regarding more or less the type of environment or the type of asset they are focused, okay? So we will start with a multi-domain project, which is piloting, and then we will cover projects related to chips and ports, also electrical distribution, which is long range ones. Then civil infrastructure, we have also, is important, we have a number of projects. Oil and gas sector, which is also a very important one. Airports, renewable energy infrastructure, and lastly, projects that are here to promote robotics and spatial maintenance, like the RIMA Digital Innovation Hub, RIMA Network, the Metrics, which is a project that organizes competitions, Aerocam, which is international training network in order to train new PhD students, but focusing on inspection and maintenance with aerial robots in this case, and Robotics for EU, okay, which is also interesting project in order to see what is the impact of the assess the impact of robotics in our society, and they also cover inspection maintenance specifically. So let's start with the first project, okay? And then, as you can see, we only have 15 minutes per project, so I will kindly ask our speakers to try to fix into these 15 minutes. And for the question and answer, if we finish, we are in good shape, maybe we can have one question or something like that. If not, at the end of the presentation, if not, please, I will ask the speakers to use the questions as and tools, so that everybody can send the question through this questions tools module, and then the speakers can answer to them directly. Okay, so let's start with a piloting project. This is a project that, as I said before, we are coordinating for Acatec. We are 14 partners, okay, and we started the project 1.5 years ago, 1st of January 2020. Well, the main motivation, as probably most of you or most of the projects here, is that okay, we need to make use of novel technologies or new technologies in order to improve the inspection and maintenance procedures. Okay, European infrastructure are aging. Okay, and it's important to develop new solutions in order to decrease the cost of inspection or increase the coverage of the inspection. Okay, and this is why this is important. Well, as you can see, unfortunately, there has been a number of accidents, even in Europe, in the last years, both in the civil infrastructures and also in the oil and gas sector, in this case for piloting. And we can think that the use of robotics and artificial intelligence can, first, decrease the cost, increase the accessibility, decreasing the risk, and also it's important improve the quality of these measurements in order to make it more repeatable. Okay, so this increase of efficiency, we think that it could be very important in order to change the way this inspection and maintenance procedure are being held today, so they can be increase the rate of this inspection. So hopefully this type of accident can be decreased or can be or not to happen. Well, piloting, the overall project objective of this project is to adapt advanced robotic technology, okay, to the user needs. So this is a project that we are targeting a high TRL, TRL7. So the idea is to develop, or the objective is to develop experiments in real assets, in real scenarios, okay? Also, we're going to develop what we call the piloting inspection and maintenance platform. This is an open and scalable platform that I will explain later. It's a software platform that facilitates the use of robotics technologies in order to develop new inspection and maintenance applications. Okay. Of course, we also want to use the project to overcome the current barriers and to promote the European robotic solution within the inspection and maintenance industry, as we are doing today. Regarding the technical part, we are focusing on piloting in advanced autonomous robotic systems in the way that we plan to use a robotic system that they have a high level of autonomy, not fully autonomous, because we think that it's not the solution, but a certain level of autonomy that facilitates the operation of this type of vehicles, both ground and aerial, in complex environment. So you don't need a very specialized or with high skills technician, operator, in order to develop this inspection operation. Also, we want to develop artificial intelligence algorithms for inspection analytics, especially with images, in order to automatize the detection of defects. In order also to increase the use of robotics systems and to decrease the barrier regarding the training of the operators, we are developing a generic robot control station. At least that for the planning and the supervising of the mission, you can use the same type of interface for all the robotic systems. Then for the mission, maybe for the sensor, thing like that, you have a specific one. For the supervising of the mission, you use the same robot control station for all the different robots. And of course, we plan to validate this project in 3 different scenarios: refineries, viaducts, bridges, and tunnels. Okay, these are the 3 scenarios that we are targeting in this project. From our experience with in other projects, we thought that it was very interesting, not just to follow the typical design, development, integration, and validation in just one step over the 4 years of the project. We thought it was interesting to have at least iterative and incremental development in at least 2 phases. Okay, so that's why, in order to gain experience, okay, maximize the probability to reach this level TR7, gain experience and use this experience in order to improve both the robotic vehicles and also the algorithms that we are developing. So in the first 32 months, we have the first prototype of the piloting system. We are going to cover at least the most important requirements, and we are going to get experience for testing in real sites. In a second phase, okay, for the last part of the project, we are going to improve getting advantage of the system that of the experience of these first trials, and we're going to perform this final validation. So we thought we hope that it will be beneficial for the project. We are right now finalizing the design and the adaptation of the robotic vehicles and the algorithms. And now in the project for the second half of the year, we are going to start with the first integration works. So what are we going to do in piloting? Well, in piloting projects, we are, as I said before, we are focusing in 3 different assets: refinery, viaducts, bridges, and tunnels. Okay. For the refinery, we are going to focus on 4 different use cases: inspection of large structures. Okay. Like for example, a tank, big tanks. Pipe inspection. Okay, that is more specific. Vessel inspection inside the vessel, and also what we call ground monitoring, okay, which is having a ground vehicle in order to be able to monitor if something's going wrong, we be able to close and open some valves and things like that. For the viaduct bridge inspection, we have the following use cases. We have the visual inspection, both general inspection and a detailed one. Then a very specific use case regarding the bearings. The bearings is, as you can see, is something that is here. Okay, that is a material that is well, more or less material that is used to connect these 2 parts of the bridge of the viaduct. And this is something that the end users are very interested in. Okay, to be able to inspect because the access is very difficult. Okay. Sensor installation as well, to install sensors so we can monitor once we, for example, we have detected some cracks, something like that. It's important to install some sensors so they can monitor the status of the viaduct over time, because for the end users this is something important. And then, of course, survey target installation, that this complements the visual inspection. So once we detect a defect, we can install some survey target so we can then monitor and see if the failure is increasing in the size or is evolving in some way. And then for the tunnel inspection, we have 2 general use cases. The general inspection one, which is mainly to have an overview of the inspection, okay, and then the local inspections. Okay, in the general inspection, we are going to use a ground vehicle where we are going to be able to get images and detect defects, but without measurements, and also have a 3D reconstruction of the tunnel. And for the local inspection, we are going to use a drone along with the ground vehicle in order to see to measure these defects that has been previously detected. So these are the use cases that we are focusing in piloting. There's a large number of them, 10 use cases, and we are going to use adapt different vehicles. This project we are basing on the experience from previous inspection and maintenance projects, okay? And we are going to adapt these ground vehicles in order to increase the TRL and then adapt it. So for large structures, we're going to use a contact inspection drone, which is called Aerocam. For the pipes, we're going to use what is called hybrid, which is an aerial vehicle that can land on the pipes and then can use a satellite robot in order to perform the inspection at different position of the pipes. For the ground monitoring, we're going to use what is called a rising, which is a ground vehicle from Robotic, and they can have a manipulator on board, and this is something they are improving and developing from a previous product. And for the pressure vessel, we're going to use base and improve the bike platform from Weight Technologies. For the viaduct use cases, we have two main platforms. One is the Aerocam, which is a drone which has the possibility to navigate autonomously without GNSS, and it has a high definition camera, and this is for the visual inspection. And then for the three other use cases, we're going to use the same base, but with some modifications that allows to adapt it for the different use cases. For example, for the bidding, the drone will be able to be connected to the upper part of the viaduct, and it will be able to go very close to this bearing position. Then it will have another configuration for the sensor installation and a different one for the surrogate target installation. But it will be some modification of the same base, which facilitates the maintenance of the type of platforms. Finally, for the tooling use case, for the general inspection, a ground vehicle will be used that will allow to take images and perform a detailed 3D reconstruction of the tunnel, okay? And then for the local inspection, a drone will be connected to the ground vehicle, and this will be the one that will take much closer images from the tunnel, okay, than with the cart vehicle. So these are with these close images, we will be able not only to detect, but also to measure the type of defects, okay? So once this has been introduced, the project objectives, the different use cases that we're covering, the different robotic vehicles, one important part of the project is not only focusing on the, I would say, robotic technology part, but also develop what we call the piloting inspection maintenance platform that will facilitate the development, the adaptation of these robotic vehicles in order to offer a complete solution to the end users, a complete inspection and maintenance solution, not only involving the data gathering, but also the analysis of this data and be able to, in a proper way, in an automatized way, facilitate the analysis of all this data that has been gathered. So what is the piloting inspection maintenance platform? It's an ecosystem that facilitates the use of robotics in inspection maintenance operation. It's one platform, one set of software that can be used with any robotic system. So it's the same platform that can be connected to the different robots in the project and in the future to other projects that maintains a certain interface. And it's a digital, secure, and automatized the management of the data captured by the robotic system. So we use the robotic system in order to facilitate to make it more cheaper and quicker the capture of the data, and then less expensive. And all this platform will be used to automatize all the management of this data and facilitate the analysis of it. So as I say here, you can see on the right a very high level picture of what we call the platform. The platform is composed by a set of autonomous functionalities that connects the vehicle to the robotic control station. So we have this standard interface, and also provides a layer with some level of autonomy functionality. So the robotic vehicle can, for example, follow a predefined inspection plan, or can be able to perform some tasks, high-level tasks, in an autonomous way. Okay, so this is mainly this is the part that allows, this autonomous functionality allows to connect any vehicle to the piloting inspection maintenance platform. And then we have a data management system that manages all this data in a detailed way and connects this information with the artificial intelligence modules and also with the visualization portal. So it's all this infrastructure support operator and inspector, facilitate daily inspection tasks using robotics, is versatile, can be used with any robotic vehicle, can be also will be used to several domains. So it can be used to in piloting in 3 domains, but in the future with any kind of domain, and also includes some security measurements and transparent data management. So what are the key features? Okay, so it's asset-centric approach in the mission design. So the mission design will be focusing, taking into account the asset properties. It allows data collection from different robotic vehicles. It stores the data in a secure way. It facilitates or allows the process of the information using artificial intelligence models, and also facilitates the view of the analysis of the information in an intuitive web portal. Okay, and all this information can be also stored in order to use third-party tools if needed. So going a little bit more in detail, not much, but more in detail. Okay, so the high-level autonomous functionalities is something that allows to perform robotic inspection using high-level assistant modes. For example, navigate with obstacle avoidance, trajectory planning, follow pre-planned flights or trajectories. So the main objective is to minimize the required training and abilities of the robotic operators. Regarding the robot control station, it's a generic one. Okay, we are developing generic one, supports several robotic vehicles, and in order to reduce the training and facilitate the use of different robotic vehicles by the same operator. And then we have the data management system that allows to automatize and manage easily all this data. Can interface with existing commercial sensors also and other inspection platforms if needed, and also with the other services, the artificial intelligence models, and also the visualization portal. Just to finalize, in piloting, we are also developing artificial intelligence that will automatize the defect detection, especially in images, okay, mainly taken from the robotic vehicles. And also this web user interface, this visualization portal that allows to create and plan missions, has overview the results, has export the results, and also have automatized the generation of reports. And this is a mission-centric and asset-centric approach. So it's important that we are taking the mission and the type of asset in the middle of how we design this type of tools to facilitate the use of these tools by the end users. So at the end of the day, this is a one-stop software platform that the idea is that will facilitate the use of robotic vehicles in inspection maintenance. It will have an open source version by the end of the project. This is the objective, and it will be demonstrated in real world cases, in the refineries, in tunnels, and also in viaducts. So I hope they were interesting. If you would like, this was a very brief introduction about the project. If you are more interested to follow up this project, please, you can sign to the piloting user group. You can just have to send an email to pilotingproject@catech.aero, okay? This is an email, so just send an email. We will include you in the user group, and you will get updates of the project, the newsletters, and other events that we are developing. So thank you very much for your attention, okay, for taking the time for being here. I think that, okay, perfect. So I hope it was interesting, okay. I will go to the questions right away, but let me introduce our next project, okay? So here we have Alessandro Grasso from RINA.
Hello.
Are you connected? Hello,
yeah.
Alessandro. Hello. It's a pleasure to have you here. He's the project coordinator of Robins, and he will present us this is going to be the first of the 3 projects about chips and ports. So Alessandro, thank you very much for being here, and the floor is yours.
Thank you very much for organizing this very interesting event, for the opportunity to present the project. My name is Alessandro Grasso, and as said, I work in Arena, which coordinates the project. So let me share the screen. Can you see it? Okay.
Yes, perfect.
Very well. Okay. Robin stands for Robotics Technology for Inspection of Ships, and is a collaborative project, of course, founded within the Horizon 2020 program. And it was a 3-year project, which, however, has been extended of 6 months due to the COVID pandemic. And actually started at the beginning of 2018, and so tomorrow will be, in fact, the last day of the project. And its scope was to fill the main technology and regulatory gaps that representing a barrier to the adoption of robotics and autonomous system in activities related to ship inspections. First of all, I would like to briefly introduce all the partners of the project, which put together companies from the maritime industries, RINA, Lloyd Register, Ship Survey and Services, Fayard, and Glavkos Marine, from the robotic industry, Friability and Wygate Technologies Robotics, expert in industrial 3D software solution, Open Cascade, and from academy with the University of Balearic Island and the University of Genova. Why RAS? Why introducing? We should introduce RAS, robotic inspection technologies in ship inspection. Indeed, this is a very good question, particularly considering that the maritime industry has a very long tradition. And of course, they can improve personal safety, reducing the need for humans to enter in confined space, work at height, example on cherry pickers or scaffolding, or performing potentially dangerous activities, like, for instance, the rafting surveys. It is also expected to reduce cost and time for the inspection, and limiting, for instance, the need of building scaffoldings and potentially reducing the vessel downtime. And finally, this technology could strongly increase the amount of data collected during the surveys, and at the same time, they can simplify and improve their exploitation, taking advantage, for instance, of the automatic data localization and advanced analysis tools. The environment of onboard ships represent, of course, a challenge for the robotic technologies. And first of all, since they are employed in confined spaces and ship structure are generally made of steel, drones cannot rely on GPS and compass for localization and pilot assistance. But nevertheless, for being effective in the inspection tasks, they need to provide in a different way this kind of feature in order to ease the operation and to provide, for instance, adequate stabilization for proper data capture. And also, semi-autonomous modes are, of course, a strong added value in the inspection task. Platform need, of course, to be protected against collision, and this can be achieved both with a passive approach, so for instance with a protective cage, or an active approach based on sensor and collision avoidance systems. The platform needs, of course, to be able to reach the areas to be inspected. And so, for instance, a drone should be small enough to pass through the manholes, or the crawler is to be able to climb and reach the point of interest, overcoming any obstacles on the way. Platform should be, of course, able to work in dark, dusty, and dirty environments. And in most cases, a proper lighting system is required with the capability to manage the light intensity and direction for avoidance, for instance, flashing on reflective surfaces, and improve the capability of detecting defects. The platform should be also able to provide reliable thickness measurements or high quality picture and videos suitable for assessing the structural condition. And furthermore, the images are to be with very low distortion despite the range of view of the camera. And other potential issues are related to the range of stability of the radio signal, as well as battery duration, but also safety and dependability of the robotic platform in harsh environments like the one on board ships. And finally, tools like advanced image and data processing should be considered for improving exploitation of the collected data and reduce the drawbacks related to the fact that the surveyor cannot directly assess, physically assess the structural condition. And so, for instance, automatic data localization for both picture and thickness measurements and defect recognition tool can strongly support the inspection activities, while a 3D model reconstruction can help in keeping the overall feeling of the inspected spaces and provide a reference for assessing the degradation evolution in time. During the project, 3 platforms have been actually developed. 2 are a platform for visual inspection. One small collision-tolerant drone, Helios 2, developed by Flyability, suitable for the inspection in narrow and highly irregular confined spaces, like, for instance, ballast tanks or double bottom. A semi-autonomous quadcopter drone developed by the University of Balearic Island for the inspection of wider spaces like cargo hold. And the third one, which is a magnetic roller, the bike platform developed by Wygate Technology Robotics for performing thickness measurements in cargo holds. So just having a very quick overview of the platform, Helios 2 with an overall dimension just below 40 centimeters fits standard manholes and so can enter almost any space on board. The drone is an evolution of Helios 1, and during the project, the capability mostly developed regarding the ease of piloting, which is required, of course, for performing good inspection. The drone is provided with sensor, which allows, in fact, its stabilization in a complex indoor environment. For instance, as I said before, tanks can be dusty or moisty, and this can be, for instance, disturbing the visual field of the optic flow sensor and should be considered in the development of the platform. Another important point was the development regarding the lighting, which are highly adjustable and include the oblique lighting feature, which is the identification of defects. And the ease of reporting has been considered with the development of a reporting tool allowing the synchronization of the video feed with the localization of the drone on the map obtained with a visual SLAM and IMU data. The other drone incorporates a number of autonomous functionalities, keeping, however, the man in the loop. Of course, it requires a redundant sensor and computing power, and therefore a larger payload and platform dimension. But as I said, it was foreseen to be used in wider space. The operator can follow and control, if needed, from a ground station designed for short deployment times and developed using a web-based graphical interface. When this drone is teleoperated, it can be controlled by means of qualitative commands and simple interaction device. The platform control software provide assistance with stabilization, speed and height control, position hold, and self-preservation tools, like, for instance, the collision prevention and avoidance. Otherwise, as in the video here below, it can collect visual data autonomously, taking also advantage of a live point cloud volume reconstruction, which allow to assess the actual coverage of the inspection. As anticipated, the other platform is a crawler able to cross 90-degree corners and climbing with its magnetic wheels on steel surfaces. In order to perform thickness measurement in cargo holds, it has been fitted with a set of tools. First of all, an actuator with the UTM sensor, but also a LiDAR and a 3D camera for localization and support to the operator. It is not autonomous, but it is able to provide its position and orientation to the operator at the ground station, together with the picture from front and rear cameras and other useful information for piloting the platform, which, by the way, can also be controlled from a remote, as we did for the last test. When the location of thickness measurement has been reached, the sensor is placed and the measurement is performed, storing the value, the location, and of course the raw data in the database. Another interesting progress is related to the software tools. The idea was to create a framework developed by Open Cascade, which could put together visual data enhanced by a photogrammetry pipeline for 3D reconstruction, thickness measurements, and defect detection tools for supporting the surveyor, and allowing a sort of virtual inspection in the post-processing phase. And particularly, it was found useful the possibility to automatically locate the gathered picture in the space and to take advantage of a reconstructed 3D model for reducing the risk of losing, as I was saying before, the overall view of the structural health of, for instance, a compartment. In this video, you can find an example of a reconstructed model, both by point clouds and texture mesh, made using pictures only. Results of the 3D reconstruction are still not good enough for an actual application, and further developments are for sure required, but what obtained so far seems in any case promising. And this is a very quick examples of detection results obtained by semantic segmentation using deep learning technique with tools developed by the University of Balearic Island. And at the beginning, I referred to both technical and regulatory gaps. Considering this latter, of course, the most important challenge is the assessment of the equivalence between the outcomes of RAS-assisted inspection and the traditional inspection procedure. And I would like to highlight that these new technologies are not supposed to replace the judgment of the surveyor, but are to be considered as new tools used for providing the required information in a different way. And for doing this, and also for allowing an assessment of the performances of RAS, it was required, of course, to develop criteria, standards, and repeatable testing procedure and metrics for evaluating, of course, the performance. And in order to ease the evaluation of compliance, it has been designed and implemented at the University of Genova a testing environment we call testing facility, where repeatable tests and measurements can be performed. Of course, testing the testing facility has been altered by test on board in order to perform a complete assessment of both the platforms and the testing facility capability itself. Unfortunately, the COVID pandemic made impossible on-board field trials and comprehensive test session in the testing facility during this last period. But in order to overcome this limitation, remote testing sessions have been set up in the testing facility. And for instance, the crawler, which was shipped there, was operated remotely by Wygate Technology Robotics, and partners could follow and interact through video calls during the test session. And just a very quick overview of the testing facility, which is divided in 3 sections: a section dedicated to survey simulation with a qualitative reproduction of an onboard environment by carrier hold, double bottom, and ballast tank. And this part was built with waste material coming from real ships with real defects. Another one dedicated to specific tests in controlled environments. And a last one which implements a relatively large mockup with repetitive structures. So thank you very much for your attention. Of course, this was a very quick overview. You can find more information at the project website, and of course, we will be happy to reply to any question if you contact us.
Okay, thank you very much, Alessandro, and also thank you very much for being on time. It's Very nice project, and almost at the end, so
Yes.
we are just a few days. So we'll keep in touch. And also, one of the other speakers was telling me that there are a lot of synergies, and probably we will see even more for the rest of the project. So,
hello, can you hear me, and can you see
yeah,
my slides?
perfect.
Hello, thank you very much. So I'm James Urden. I'm representing the RAPID project as the coordinator and principal investigator. So this project is led by the University of the West of Scotland out of the Almada Research Centre. So we're a 3-year project and we are 1 year in. So RAPID basically stands for Risk Aware Autonomous Port Inspection Drones. So in terms of the objective of the project, we are focused on, as you said, maintenance inspection in port and harbour environments, very much at the intersection of land and sea. So to achieve this, the approach that we're taking is we're integrating drones with an unmanned surface vehicle. So the vehicle that's shown on the screen here, that's provided by our partners, X-Ocean. So I think similar to most other projects in this workshop, our motivation has very much come from some of the high profile tragedies around bridge collapses in the last number of years. And I suppose the statistics that have emerged around that, where 1 in 3 bridges are classified as high risk of collapse, but we don't know which ones specifically, because we don't have the level of insight and condition monitoring that we need to be able to identify bridges before they're at risk of collapse and to perform preemptive maintenance. Within this project, because we're looking at, I suppose, the intersection of land and sea, we've 4 target use cases that we're focusing on. So the project itself is embedded in the Port of Hamburg, which is the 3rd largest container port in Europe. The Port of Hamburg itself is situated in the city of Hamburg, so it's a city port, and productivity gains really can only be found by improving efficiencies within the port, because they don't have any additional land or space to expand. It's an intermodal epicenter, obviously connecting rail, road, shipping networks. Majority of the bridges that we're looking at are those that are accessible by water through the extended reach and remote mission support that the unmanned surface vehicle can provide in terms of the energy management and being able to deliver more significant compute at the edge. But we're also looking at the shipping aspect of this in terms of inspection of ship hulls, in particular when ships are on approach to port. So the operating site here within the Port of Hamburg, it would cover 20, 30, 40 kilometers easily, because the port is inland at the end of the River Elbe. And to reach out along the port and out into the coastal zone, it's beyond the endurance of any off-the-shelf drones that are available at the moment, apart from fixed wing, which aren't suitable for this type of maintenance inspection task. So we're looking at emissions monitoring to detect noxious gases, bridge inspection, ship hull inspection, and emergency response if there's a ship-ship collision in the coastal zone, to be able to provide emergency services and Coast Guard with eye in the sky situational insight. And the drivers here is very much that, well, we can do some of this already in a manual context, where we can take a drone, we can bring it to the situation, we can mount a sensor, fly the drone, collect the data. The current workflows are all very manually based. So the modes of operation of drones currently, it's hyper localized. They're reliant on a human pilot that's in very close quarter proximity to the drone itself. The regulations won't allow flight beyond 500 meters. So it suffers from all the I suppose the drawbacks of a manual workflow. It's inefficient, it's prone to errors, and so on. So what we're looking to do here is, as we remove the human from the loop as much as possible, then the duties and roles that the human operator would perform need to be moved either to the drone or the unmanned surface vehicle. I think, as the previous two projects have also touched on, this doesn't happen in isolation because it's very much part of an interdisciplinary, multi-stakeholder context of legal, regulatory and standards bodies. There's the public perception and policy aspect of it, where the autonomy really to be delivered through artificial intelligence needs to also very closely engage with regulators and standards bodies. So the breakdown of the project that we have structured is split across objectives that identify each of these barriers to adopting the technology. So the risk assessment now needs to consider, the airborne air-to-air collision risk that the pilot can't monitor, the surrounding airspace. The drone itself needs to have hazard perception, and the risk assessment needs to take that into account in terms of the payload sensors, the actual operating environment, and the overall theater that the drone will operate in. There's the development of the beyond visual line of sight collision detect and avoid capability itself that needs to be executed on the drone. There's the extended energy management and energy autonomy, so that we have that additional range and reach and improved duty cycle by performing the energy management remotely in the situation. There's the artificial intelligence aspect itself in terms of the seminal crack detection challenge for maintenance inspection, and then all of this having to communicate back towards stakeholders and end users, legal, regulatory, port and harbour agencies, and across both aviation and maritime contexts. And these are quite fragmented, and we don't have a consolidated framework for these types of operation yet. So the crack detection challenge is very much a standard applied AI challenge, where the end user, Hamburg Port Authority, they have the domain expert knowledge. They use drones already as part of their professional practice. They collect a lot of this data. So the availability of the labeled data sets and the labeling tools helps us to create and drive those neural network training and inference pipelines. But obviously, because we want to embed these solutions on a drone, there's hardware and software optimization required as well, so that we can operate within these low power envelopes. The crack detection challenge is very much then to drive photogrammetry and 3D reconstruction, so that we can track any changing morphology of these cracks. So they're very damage tolerant. One crack will not make a difference, but if we have hundreds of cracks and they're changing in shape or changing in depth, then this is something that we need to be able to track. So we do a 3D reconstruction, and then we use an acid digital twin as the container for the data. The other aspect of this, which I think is probably a little bit more service agnostic, and I think it becomes clear when we look at all the projects that are being presented today, is this is quite a non-stationary problem, in the sense that as soon as one drone has permission to fly, so does everybody else. And what was basically an airspace that was traditionally dominated by conventional and commercial aviation now becomes an airspace that becomes very cluttered and unsegregated in urban industrial built environments, where drones are operating in close quarters to each other, to large, complex, dangerous structures, and in densely populated regions. So the typical air-to-air collision hazard of an unexpected incursion from, say, a low-flying Cessna, which would be a very remote event but would have catastrophic consequences if there was an air-to-air collision. In terms of drone-to-drone collision, this now becomes a very frequent event, and is something that requires very robust and reliable hazard perception AI to be deployed on the drones themselves, so that they can monitor their surrounding airspace and sense and detect unexpected, uncooperative, unpredictable air traffic, and perform avoidance maneuvers. To get ahead of this, the regulators have laid out their roadmaps in terms of the European Union Aviation Safety Agency in particular has laid out its regulatory roadmaps and some of the initial deliverables around validation and machine learning, which seeks that any AI that's brought into aviation and unmanned aerial systems now will need to be trustworthy, it will need to be explainable, there'll need to be assurance over the learning process, and it will need to incorporate all the security, ethical and privacy concerns of public society and regulators in general. So this is something that, again, emphasizes the interdisciplinary challenge of this work, but at least it lays out a roadmap in terms of, okay, while we don't currently have a standard for detect and avoid, at least the major stakeholders in this area are working in that direction. So the approach that we're taking on this is our partner, Hamburg Port Authority, they're a smart port. They actually have a digital twin of the port environment. And it's within this digital twin that we're performing a lot of the early investigations and understanding of how these hazard detection sensors actually operate. So being able to simulate them in the actual virtual theater to virtualize the risk and cost of validating these technologies, and then bringing in techniques from, for example, software engineering, where we use proper DevOps versioning and validation tools to be able to track the learning assurance and the explainability of the systems. So what we're actually doing here is we're taking digital twins of the port environment, augmenting them with those small air-to-air collision risks of small aircraft, other drones, birds, helicopters, and so on, and then bringing in and augmenting high fidelity models of the sensors themselves with all their directivity and systemic biases that they have, because they're non-uniform imaging patterns, in particular LiDAR, but we're also investigating thermal, radar, and RGB systems, and using this platform to provide early understanding of the perception capability to be able to predict the performance, but also to be able to optimize the scanning patterns and so on. So this is basically the objective of this line of the work, where we're going to build this up in the Port of Hamburg, and then in 2023 actually perform validation demonstrations with the end objective of being able to digitalize the specific operation risk assessment that's currently used in unmanned aerial system operations. So that's a very quick overview of the project, a quick introduction to the team. And I'll just use the opportunity to say that we have a workshop at the beginning of October with our sister project, Drones for Safety. If you'd like to know more about the two projects that are collaborating here, and there's currently a call for papers out, and I have it linked in the slide above. So thank you very much.
Okay, thank you very much, James, and thank you again for the for being on time. Okay, it was very interesting, and personally, I'm very interested in this safety part. So we'll have a look to this workshop. So I hope you the best in your project, and we hope to maintain contact. Okay, so probably there will be some questions for you, so you can answer them. It could be great. Thank you again for your participation.
Thank you.
Thank you. So now we'll go to the next project, Bug-Ride 2.
Thanks for joining this presentation. So I'll be presenting Bug-Ride 2, which is titled Autonomous Robotic Inspection and Maintenance on Ship Hull and Storage Tanks. So in a way, very similar to what we've seen so far. It's a very quick presentation, so just to give you a highlight of what have been done so far. This project started last January 2020 and was hit full on with the pandemic, so a little bit of a challenge to manage that. So the idea we had at the beginning is actually illustrated by this cartoon on the top left here. We started with the idea of a fleet of vehicles moving around these very, very large metal structures that we have on ships. We are concerned mostly on the outside hull in comparison to Robbins. I mean, basically there's a continuity between Robbins and Bug-Ride 2, and some of the partners from Robbins actually are in Bug-Ride 2. But here we are looking more at the outside hull with fleet of heterogeneous robots starting from outside, drones, as we've seen in other platforms doing visual inspection, underwater vehicles looking at the hull below water, and some crawlers also moving on the hull outside. All of these vehicles collect data around the hull and will bring in this data into 3D immersive representation that can be used by inspector or the experts in an immersive environment. And then all of that will have to be tested in the real world. So Bugright 2 is a fairly large project with 21 partners across Europe, going from 11 academics, SMEs providing robots, service providers like marine surveyors, shipyards, harbors, and then supervised also with a classification society. So RINA is also in there, and some asset owners bringing in the ships. On the academic side, we have the typical technology providers on robot experts, but also some inspection technology experts, some legal experts, which I think is actually something which is quite interesting in Bugright, and some human factor expert bringing in the work psychology aspect. The idea is similar to what we've seen so far, and actually what I've seen this morning so far leads to the ideas we should use more synergies. So the idea is to start with some kind of model of the structure to be inspected, allocate it to multiple robots, plan a mission, then have all these robots move around, autonomously navigate, collect data, and export it to some monitoring and review process. Again, something very similar. And then later, there's a second stage of looking at this data by the expert, analyzing what's important, and going toward actionable items. In Bugright 2, we're looking at two types of inspection. We do inspection for the review process, certification process, but also we're looking at cleaning, because hull cleaning is something that has a huge economic and environmental impact. And we want to also address that, given that the technologies from a navigation point of view are very similar. So without further ado, I want to go to some of the highlights. So if we look at what's done in practice, so there are some pictures by some of the partners in the project. So basically a ship is put into dry dock, and then scaffolding is put all around it, and then inspection and maintenance done on the hull. Using cherry picker, using scaffolding, a lot of manual work. What we see on the bottom right is work by one of our partners deploying a mobile platform, but again, it's a remote operated system where data is watched by a human, and when a defect is detected, then everything is stopped and someone take a chalk and go and draw on the hull and say, okay, there's a problem here. Very manual, traditional process. That's what we want to make evolve. But actually, when we started by the analysis on the constraint and text regulating all of these processes, starting with ISOs and all the different rules of ISOs. And then this is not designed to be read, but our legal partners went to all the text, national, EU level, worldwide level, that are involved into all of these inspection regulations. And basically the conclusion that it's a huge maze of text, all interleaved into each other's, regulating just the use of remote operated system into inspection processes. We also looked at the work processes from a work psychology point of view and identifying all the steps. Something we hadn't really forethought very well at the beginning is the importance of the preparation work, where there's also some automation and support system can be brought in. Then cleaning and robotics has a role to play, but it's actually something which is quite small in the middle. And then there's a big stage on reporting where we can bring in immersive technologies. So then now if we move to the technology side, so some of the development were on getting some of the crawlers to be underwater ready. So there are kind of prototypes being developed right now, tested on real ship hulls, which are currently berthed on the Loire River, very muddy water. So this work in progress shows what's possible with the inspection systems. We just pause that while it's being sent. And then what we want to go toward is something which is much closer to autonomous inspection as we know it in robotics. So there are some examples of autonomous navigation and data collection in 3D, which are done basically, well, ideally we would have wanted to test that on real ships. With the pandemics, we had to build our own kind of tiny hull sections at home where we don't have a ship. So that's what you're seeing on screen here. A lot of work was done also on the underwater system. So these small drones are fairly cheap drones, easy to use, easy to deploy, but at this stage have been designed for hand operation, remote control, and a lot of work was done to update them toward autonomous operations. On the drone side, most of the drones are actually off-the-shelf drones, as we've seen in the other presentations. But what we focused on here is the interfaces, to design interfaces which will support inspection processes for large structures, mostly helping to design sweep missions, to supervise sweep missions without having to do very fine-grained planning. Some intersection also between Robins, a lot of works on image processing and detections of, in this case, corrosions, but basically issues, defects on the environment. We also have some group of people working on the acoustics part, and that, but I didn't include presentation here. On the multi-robot aspect, because we said that one of the difference and one of the challenge here with Buggerite 2 is to deal with multi-robots, so that's a little bit lower TRLs, a little bit further from the market. But how would we bring in multiple robots, and how do they share such a very large structures as what we have with the ship environment? And that brings also a problem with user interfaces. How do we bring the data collected with all these different systems into immersive environment, which can still be manageable by the inspector, which at the end has to sign, okay, I've seen all the hull, and I can say that everything has been inspected. Actually, quite a big challenge here on creating the user interfaces and integrating with the certification requirements. Because it's an innovation action of the last call, and we have to build pilots, so we're working with the end user to start deploying our robotic platform. So with Gulf Coast Marine, which is a marine surveyors going on site, starting to offer services, integrating with the certification. And recently we got one survey which was actually validated by a class society. So we are going toward integrating with a class society, seeing exactly what's required. And this legal aspect is a big part of the project, which is actually as complicated in a way as a technical development that will go toward autonomy. One thing to see here is in terms of dichotomy, is that certifying the devices and the processes is one thing. Developing autonomy is another thing, but getting autonomy to be certified for use in the actual inspection is yet another stage, which is actually looks a lot further from the market. Some examples of like deployment and test in real environments as a real ship after sandblasting, before painting, where the system were deployed by the marine surveyor. So that gives you a quick overview of what Buggerite 2 is about. So I try to aim for this 10 minutes and leave the floor open for questions. So I don't know if Attilio, you want to have a bit of time for open questions, or if I just
yes, of course, we can take advantage of these 5 minutes. I don't know if from the people that are seeing the workshop, we are over 100 people. So if you have any questions,
because we also have this ships and ports thing. I mean, I think one word I would like to say is that I see a lot of potential synergies. We are developing things which are similar. The user interfaces looks, well, similar in purpose if they're not in exact details. But I also see the advantage of the development of mockups. So for instance, what Alessandro was presenting with the mockups and the test facilities, it would be super interesting to have access to that within other EU projects. And I think we can, if we could take advantage of this workshop to basically roadmap towards that, that would be very, very useful for the EU and for everybody here.
Yeah, of course. This is one of the objectives of this workshop, is to increase the cooperation between European projects. Okay, so for example, I also noted that this test site could be interesting for the projects, or to get access, or even just to know each other is interesting, you know, to know what the other projects are doing and explore possible synergies. So that's
one of the challenge we have in our case, that we want to inspect ship hulls, but clearly if we talk to ship owners and you ask them to stop the ship for a couple of weeks for the researcher to work at about 25K a day, they're not happy. So clearly we need test facilities, validation facilities that can be used to validate the system, but also to train future engineers and surveyors. I think there is
even
big
to train
potential there.
operators, as you said, the real sites are very much complicated. It's difficult to get access. It's difficult to even it's usually difficult to get access to do a real inspection. So in order to do research, even more difficult. So as you say, it could be also interesting to maybe as a result of this workshop to in some way identify, because for example we are aware of other research facilities that have some testing sites. So identify testing sites that people can make use it for inspection and maintenance. It can be done for research, or it could be for training, or for benchmarking. Could be as well a very interesting part. So I don't know if I think the people that not having questions so far. Anyway, Cedric, thank you very much for your time, for participating in this workshop. Please stay. I mean, for the rest of the presentation, but maybe you can stay for a few. Maybe if someone
for a bit.
What?
Yeah, I'll be around for a bit.
Yeah. So if anyone has any further question, okay. Yeah, there are people say if we can get the email address, I will say that most of them you can get it through internet, but with respect to the protection data, we cannot facilitate them directly. But I will answer this question. But anyway, for the speakers, most of the speakers, I found the emails address through internet when I started to organize the workshop. So you can probably get it through internet if you are interested. So again, Cedric, thank you very much. And I think we can go to the next part. Okay, so this was everything about chips and ports. Okay, it's a very free, interesting project, Robbins, Rapid, and Bookwrite 2. Okay, and now we're going to change the domain. We're going to the electrical distribution with aerial core. That is going to be presented by Aníbal Ollero, full professor at University of Seville. Aníbal, I cannot hear you.
Hello.
Hello. Now perfect. And we can see your screen. I would
like to put my screen in. Okay, is that okay?
Now perfect, Aníbal. So whenever you want, you can start.
Okay, thank you very much. So this is aerial core. So we are focusing on aerial robotics, and also we are extended long range inspection, but also safety and accurate inspection. In the consortium, we have very strong research and innovation capabilities in aerial robotics. I think that we have very good research institution in aerial robotics, very innovative company, but also large and very committed end users. So we have the three ingredients for this research and innovation action. So I will start after the objectives and approach with the research. And then this project started in December, 1.5 years ago. And then we will go for the first validation and my conclusions. So as I mentioned, we are cognitive aerial robotic systems. So we try to apply artificial intelligence to aerial robotics, but also we have to consider aerial robot with different characteristics to meet the requirements of long range, but also at the same time local, very accurate inspection. But also we need maintenance. This is not only inspection, but maintenance activity based on our background on aerial manipulation. And also we introduce here safe aerial co-working. So working with the humans. So in the core, there is the cognition, and we use the cognition for morphing, change the aerial platform in such a way that we can have vertical takeoff and landing, but we can also efficiently go far away. We also have manipulation, and you will see also cognitive manipulation, and also for the co-working. So we are researching in these areas thanks to the cognition. So let's start by the cognition aspect. So first, we want to recognize and to apply deep learning methodologies for detection and localization of critical power line elements. Here you can see some of the characteristics that we are applying of the University of Thessaloniki is applying in fast convolution to the visual target tracking. So you can see here how this is applied to insulators in the network. So this is fully autonomous recognition and then tracking. But also we want to detect the surrounding of the electrical line, because for example, we want to see the vegetation and so on. So we have a couple of nets for the segmentation and for the depth measurements, so that we need these depth measurements. So we have all this. Additionally, we have the sensors from the Teravi, the company Teravi. And particularly, we have a 3D VGA camera for to perform human gesture, because we want to communicate for the co-working with the human, but also obstacle avoidance in close distance, takeoff and landing, and so on. So you can see some of the images for the inspection depth and infrared images. We want to analyze not only the conventional, but also even in the base of the towers that we want to inspect. Also the ground aspects of the electrical grounding. So, and also we have a radio frequency based relative positioning to know the relative position between the aerial robots and the human workers. So we tested at the University of Seville testbed with this equipment coming from Teravi, and we will implement in the electrical lines. So the University of Zurich is working on the perception, but particularly for long-range power line tracking, and also for the Pershing. So to do that, it is necessary to be very efficient, but also at the same time robust to high dynamics. So they are using, or we are using together, event cameras for event power line tracking. Because these cameras, as some of you know, they have high dynamic range, and they are also more less sensitive to the motion on board the UAV, on board the multi-rotor. Also, it is possible to differentiate between different backgrounds and so on. So there is a very active research in this topic. Okay, but also at the University of Seville, we are working on mapping. Mapping here is not only the conventional mapping, because we want to use and to combine geometric and semantic mapping. So we want to have different levels also, but also different properties, geometric and semantic properties. And we have online fusion, but also we have semantic classification offline. We are using in this 3D LiDAR, which is a multi-return, which means that we can obtain the properties, for example, not only where are the tree, but where are the background, so below the tree. So we can have the characterization of the tree and what is below the tree. And then we can have this representation of the environment, because obtaining the proximity of the vegetation to the line is also very, very important. So you can see here some properties. Also at the University of Seville, we are working in team cognition, because this is also a multi-UAV, a multi-robot inspection. So we want to plan, and we also want to have team cognitions. So we are considering in the network the regular inspection, but also we are considering the faults localization. So when you have a power outage, you want to identify as soon as possible, where is this? Where are the faults? You don't know the location, so you have to explore the power grid. And then we have a inspection problem, but also we have a planning problem, because we need a cooperative fast inspection with a team of UAV. So we have a multi-UAV planning problem with several UAV at the same time, heterogeneous. You will see later in the validation that we have fixed wing, or we have multi-rotors, but also we have hybrid, because they can take off and landing as vertical and also fly like a fixed wing. So we have to consider all these characteristics, and we need models to characterize the consumption, the energy consumption, and the cost. And we have constraints due to the communications, because we are flying kilometers, but also we have to take into account another important characteristic, which is how to recharge the battery. And we are recharging the batteries in both ground platform, but also in the next year, we are developing recharging on the line, on the electrical line. We're using the electricity of the line. All this we have to consider for the planning problem, which is a complex. And then we also want to consider the wing, for example, which is very critical for our small aircraft. How is the wing? So that means the direction and also the velocity of the wing. The university, Czech Technical University, is also working in this project with us, and we are together working in optimization techniques like the TSP approach for solving all these complex planning problems. Okay, now let's go to the platform. We have many platforms for many years coming from different partners, multi-rotor, fixed wing, but also, as I mentioned, vertical takeoff and landing, plus having also flight like a fixed wing with a single propeller. And also, in addition of this dual system, we have also now a partner which is able to fly by tilting the rotors in such a way that there is a vertical takeoff and landing, and also again flying as a fixed wing and more efficiently. And also we are able to recharge the battery, as you can see here. Okay, but also we have research on this topic, and the EPFL in Lausanne is working in bio-inspired approaches. And then by using these bio-inspired approaches by two sides. One is to have this from the Electron, we have ideas to how to morph. That means to have vertical takeoff and landing, but again, to fly as fixed wing. So morphing the wings. And the second, and also very relevant, because you will see later that we need manipulation, then we need to perch on the line. So they're developing some perching mechanism, bio-inspired also, to perch on the electrical line. So we at the University of Seville, from my advanced grant in the European Research Council, we have flapping wings. But here we wanted to increase a little bit the TRL, and then we are combining in this hybrid system the flapping wing with also a single propeller to, let's say, to fly, combining both of them, which is more easy than just negotiate the wind and use only the flapping wing, which is also very good, but also is energy consuming. So sometimes, as you can see, depending of the conditions, we will be able to change between flapping wing and also fixed wing, optimizing the energy. Okay, good. You will see that this is very integrated in electronic onboard the platform. Okay, also let's go now to the manipulation. So for manipulation, we have selected a number of cases, use cases. One is the installing the separators between different cables that you can see here. This is the University of Zagreb. But also we want to perform the installation of the recharging station. There are two cases, one of the drone and the other in the electrical line. But in both cases, we want to have robotics coupling, and then we have to develop this system. But also we are researching here in soft end effectors. So we have soft end effector with shape memory alloy at the University of Seville. And you can see here some of them in order to, for example, grasp the line with a hand and then manipulate with the other hand. And we need to install very complex system to install this, for example, helical diverters. For the bird diverters, we want to avoid the collision of the birds, and then it is needed to install these bird diverters. So you will see here that we are developing this system by using a very efficient pushing forces to significant forces, 100 kilograms here, to install the bird diverters, but also to research. We are going to install these more complex helical diverters. And for that, we need a dual arm system for that. Of course, the manipulation, aerial manipulation, will be more complicated, and this possibly will be performed landed, grasping, I mean, in the line. perching in the line. But also at the same time, the University of Naples is also developing manipulators and an effector here. Okay, now we also want to implement autonomous functionalities for manipulation, as you can see here, integrating the perception system and also the planning, because we do not are considering just the installation of a single bird diverter. We want to install many bird diverters, and this can be done rolling on the line, but also flying and combination of. So that means that we also are planning this motion and combining and integrating different platforms in the same system. Okay, now the University of Zagreb and EPFL are developing also teleoperation, advanced teleoperation system, using, for example, the EPFL fly jacket for the manipulation of fixed wing or rotary wing or even manipulator. All these interfaces we are developing in such a way that in addition of having the autonomous mode, we also have these teleoperation modes. And this is the University of Zagreb and EPFL. Okay. Now let's go. Now, finally, for the co-working. In the co-working, we need physical interaction. I don't have time to show videos here, but just to let you know that we are working on this. We have preliminary experiment providing tools to the worker from aerial robot, but also we have to identify the motions of the worker to communicate with them by using gestures, for example, but also the voice. So we are estimating the position and then working, also monitoring the safety of the workers. And also we have a team of aerial robots monitoring the different people working in a tower for the safety or to attend what they need, answer the questions, essentially. Because you typically see that there is several persons working at the same time. Okay, so now we are developing and validating prototypes from the different companies, including the recharging station and also the variable tilt is a rotor, or how to land in the electrical line. We are performing the very first experiment touching the line, so we need to consider the electrostatic discharge, and also we have to design a shielding mechanism. We started with a 15 kilovolts power line, and we are touching the line. So we plan to perform an experiment and landing on these conductors and then manipulation very soon. But we are characterizing the behavior of the controllers, taking into account the influence of the electrical line. Okay, now we are performing the very first experiment in the Fadakatec Atlas testbed with Endesa, because in this field, we have electrical lines, high tension and medium tension. So we performed the very first experiments in this scenario, having two multi-rotors and one dual vertical takeoff and landing and fixed wing, the three flying at the same time with planet trajectories, as I mentioned before. This is Atlas, so it's the center, so we can perform in real time these flights. This is a recording in real time of the flight of this fixed wing at the same time that others are monitoring. So you can see here this dual system, and then you can also see the recharging. So we have, I think, that the very first inspection of an electrical line using not only one line but several lines, using fixed wing, but also takeoff and landing and multi-rotor, everything together in optimal plan. So we have preliminary experiments, and we did last month in Atlas. So I have no time to describe all the experiments, but we're successful in inspecting the tower from the base to the insulator and everything. You can see this is fully autonomous landing by using computer vision, fully autonomous landing for recharging the battery while others are flying at the same time. So you can see here the full deployment of the system, but I have no time to describe. So I would prefer to go to my conclusion. So we are developing disruptive aerial robotic technologies involving morphing, cognitive manipulation, co-working, but at the same time, we are developing new industrial product that will be marketed by industrial company. So we have new applications, some of them completely new in the world, beyond visual line of sight, manipulation and aerial co-working. So we plan also to use this system not only for the electrical line, but also beyond visual line of sight of railways, pipe, tunnels, and so on. So we plan to maintain the leadership that Europe have in this aerial inspection robotic technologies. So just to invite you, so we have started with the validation application. We have an industrial advisory board. Industries are very welcome, but also we are looking for synergies with research organization and companies. So we want to perform a very also different application beyond visual line of sight, fully autonomous systems. So please visit our site and contact me in such a way that we can exploit our ensure synergies. So thank you very much for your attention.
Thank you, Aníbal. So Aníbal, you have some questions in the question and answer, so if you can spend some minutes, could be great. So
Okay.
now let me introduce, and thank you very much for your time and presentation. So now let me introduce Macarena Márquez, also from CATEC. She is leading the dissemination part and the exploitation part of the piloting project. Hello, Macarena.
Hello, good morning, all of you. I will moderate this second part of the workshop in which 4 new domains will be presented: civil infrastructure, oil and gas sector, airport, and renewable energy infrastructure. The speed of the workshop is very good, so thank you very much for the speaker. And I would like to remind the speaker to comply with the agenda. So let's go to the first project. The first new Horizon 2020 project is RECID and will be explained by Georgis Tikismix from Institute of Communication and Computer ICCS from Greece. So Georgi, hello.
Yeah, hello, hi everyone. So just let me share my screen. You should be able to see my screen, right?
Yeah, perfect.
Okay, thanks a lot. Thanks for the introduction and for the organizations of this really nice session. Indeed, as you said, like the speed of the workshop is really high, but it gives a very good overview of what is happening in the field. So I would like to thank also from my side all the organizers and especially Antidio for making this happen. So I will talk to you about Resist. Resist was one of the first projects, as you said, like funded in the domain of resilient transport and infrastructure. So it consists of 17 partners and 2 end users, but I will not say much about the partners and go directly about what we are trying to achieve in Resist. So when it all started back in 2017, I think it was a common finding of the community that there is a lot of great achievements in the field of transportation. But however, this is very vulnerable to extreme events. And when we say extreme events, that could mean natural causes, physical causes, or even man-made incidents, or even cyber attacks that have a direct impact on human life. And that's how came up the idea of Resist. So what we try to do in Resist, and we are working the last 3 years, was overall how we can protect users and ensure the seamless mobility, how we can prevent, predict, and increase the resilience of the whole ecosystem. And finally, how we can react once an incident happens in order to minimize the impacts and restore the services. So in order to achieve this, we have a mix of technology solutions, modeling and risk assessment solutions, but also like some procedures of reaction in case of an event. So just to see like the whole idea and give an overview of that, we have as said like a mix of wireless sensors that we can mount on critical infrastructure like bridges, roads, etc., and which has a mix of laser systems and radars, and can give us like in real time an operational image of what is happening in the infrastructure that we want to assess. And in order to achieve this, we are supported by an ARPAs, like a mix of drones and robotics solutions that are giving us the possibility to have a better view of what is happening where, and at the same time support us with the mounting of the sensors that we want to have. At the same time, we also secure the communications in case of extreme events, and that give us the possibility to be sure that everything that is happening in the field it can reach like the backbone of the system, and especially like as we know in case of extreme events, we cannot rely on standard communications. That's why we're using satellite communication system in order to be sure that we can have all the information that we have from the field. At the same time, apart from this, we also have a decision and awareness layer. Once we get all the data, we are able to assess them all together in order to take the best decision. And there is a mix of layers that support this decision making. And of course, like keeping always in mind that cyber security and cyber threats and attacks are also like a factor that we have to consider. At the same time, the users and the end users have access to all this information, and at the same time, they can be supported to take the most appropriate decisions. And in the end, we even aim to interact with end users, and by end users we mean the citizens of the infrastructure, where we can have information about how they react on the event, and at the same time give them some recommendations either to avoid or like how they should react to the event that just happened. So in order to achieve all this, Resist, as said, like has a mix of technological solutions and of course a lot of robotics, and that's why we're also here. So we are using a mixed set of aerial robots and ultrasonic sensors, and that we can put on the infrastructure. We have a computer vision systems able to identify cracks, and not only. We have the secure and resilient communication system, the cybersecurity solutions, and the mobility continuity platform, whereas also the risk assessment and management of extreme events. So as we have some more time, I think I can also show you a few of the developments that we have already achieved within Resist. So first one, we have it's already developed and adapted commercial drone that is supporting the visual inspection, and more specifically, like it has the propeller protection, as well as the gimbal for the camera orientation and stabilization, and also onboard processing of all the images. And we are ready to use and demonstrate this in the coming months, hopefully. At the same time, it was developed a contact inspection robot, and even the organizers know even better than me, like that it was quite an achievement to have this robot ready, and especially like with all the work that was done around the robotic arm, and how exactly that will move and be able to attach to the bridge. And so that was a very, very nice achievement during the project. Whereas we had also like a contact inspection robots that could also be attached to the bridge, and hopefully we'll be able to test it in the coming months. So regarding the tunnels that we would also like to include and test during the project, we also had like a contact inspection robot which has a compact design and has the possibility to assess and reach smaller areas, and especially areas that we can find that it's very limited the movements that we can have, and the whole area that the robot should cover. Finally, we also had some sensors developed, like it's a custom 3D printed design that we had, and also with an onboard computer, and it's part of the sensors that we will use for our assessment. Whereas also the vision system of the that we will have is already developed, it's ongoing, and hopefully will be tested within the next couple of months. Whereas finally, I said that we also have ready the applications for the end users, and some rerouting protocols that will take place, especially in the case of the event, and how all the people will be redirected. I said that we're planning to go on with our validation activities in the coming months. We'll have a bridge in Greece, in the northern part of Greece, where we'll have to perform the whole assessment, and also like the second pilot in Italy, in the northern part of Italy, and hopefully in the next year or less than a year, we will have the whole Resist platform validated. That is all from me. Thank you very much again for the invitation, and apologies for being that fast, but I was trying to fit everything within the 10 minutes. So thank you very much.
Thank you very much, Giorgio. I think we don't have any additional question for you. So if you can stay a few minutes, if someone wants to ask you something.
Panoptis has been selected in the same topic as Resist. So we are also dealing with resilience of road infrastructure. Next slide, please. Sorry. It means that this project is not only about drones or UAV. We have three main objectives in this project. The first one is to predict the hazards that might impact the road infrastructure. It's based on very fine prediction, but also it's based on the infrastructure characteristics, so we can assess the risk for vulnerability. The second main objective is to have an information management system. So this information management system has twofold. One is operational, so it means that the information that is given by the system will allow to keep the road infrastructure working normally. And the second aspect is, of course, at mid-term, at long-term, to have information for the maintenance of the road infrastructure. So we consider all the elements of the road infrastructure, bridges, tunnels, but also the road in normal things, because we want to detect any type of problem that can occur. Due to the fact that this project is a follow-on of Aerocam, a project that was on bridge inspection with CATEC and University of Seville, and this project was very successful. We don't focus too much on the inspection of the detailed inspection of bridges, because we want to focus more on the detection and inspection of macro event, which will be a different type of inspection. So I'm focusing only on the last pillar, which is the remote inspection by UAV satellites. But also the UAV can be, of course, as you can imagine, cars and trucks, because the owner or the operator of the infrastructure will make also inspection by vehicles, by road vehicles. So what do we need to inspect this? We need to have a prerequisite 3D model. So we are using photogrammetry or LiDAR. just to have the model of the infrastructure as it is, and after be able to detect the changes. After, we have a mission preparation for the UAVs, depending on the cases. We have the mission itself, most of the time fully automated for data collection. And finally, we have the exploitation of data through computer vision or similar things. So next slide, please. So it's the project objective is we have a user headquarter. Headquarter means operation or maintenance center. So the UAV is doing its mission through a generic ground control station that can pilot different UAVs. So as a result of previous project, but also on the concept of operation from the end users, we have several types of UAV depending on what has to be done. So the concept of operation of the system is when we are dealing with normal situation and monitoring of what is happening in real time on the road. The UAVs are just not flying, they are in reserve, and they can be activated if we have an accident, in order to make very quickly a first damage assessment, waiting for the human components to come to the place and to manage the situation. This is concept of the generic concept of operation, day-to-day concept of operation. But we also deal with maintenance and inspection, meaning that we have to do, the end user, they have to do a regular inspection of all the components of road infrastructure. And this plan of maintenance is, of course, in the maintenance center, and it can be updated with the result of the inspection. So in the case of the inspection is done remotely with only the drones UAV components. Just to make detailed inspection, and after update the referential for the system and the status of each components of road infrastructure. So these drones are mainly from two types, as it was presented by Hannibal. Each UAV has different characteristics. So we are using mainly hybrid UAV, which is a UAV that can take off and land vertically, but can fly as a fixed wing, just to go quickly to the place of interest. In order to detect big events or let's say macro events, we can use the fixed wing characteristics, taking photos. But if we want to have detailed information, we need to have a VTOL, a vertical takeoff or landing, because the hybrid UAV is still not stable enough to take detailed pictures, and we cannot detect very small or macroscopic events. Just to finish with this type of UAV, when we want when we have to assess the situation in case of landslides, in case of cracks on the roads generated by earthquake or whatever, we can use the fixed wing, the characteristic of the fixed wings, using the cameras, but also the LiDAR in some cases. And when we want to detect smaller events, then we will use a VTOL. The main drawback of a VTOL is that it will take a lot of time to reach the place, and the autonomy is quite small. So it means that we have to pre-deploy this VTOL along the road infrastructure, not to waste time on this. Next slide, please. So this is what we have done in Aerobi. So I won't take a lot of time, but it just describe what we did, the various trials that we did in Spain and Greece, just to validate the concept of use, concept of operation of this. Next slide, please. This is impact of UAV in Panoptis. Of course, there are the ones for inspection where we don't need scaffolding. We don't need to reduce. No, we don't need to have a lot of material, trucks, and teams. The second point is to reduce the closing time of the road, of course, because we don't have so much material on the road. Third point is better transportability. So we can put the ground control stations of UAV in the truck and in cars in order to do the inspection, or we can use the UAV. We can task the UAV directly from a headquarter or maintenance center, and of course a lot of money saving. Next slide, please. So these are pictures that we have from Panoptis. We have these 3D models and 3D mappings that will be used after for inspection. So we have, of course, computer vision combining deep learning and combining also more classical interpretation. So as you can imagine, we need to have a detailed situation as it is, or as it is at the beginning of the system, in order after to identify the modification or the evolutions of the situation. Next slide, please. So this is the hybrid UAV. So as you can see, it can tilt the propellers and take off or land vertically, and during the transition phase, it will fly horizontally like a fixed wing. Next slide. So this one is not upon Panoptis, it's just to show that we are using also multi-rotor type UAV for the inspection, for more detailed inspection. Next slide. So this is the information management system from UAV. So it's based on the very detailed 3D models. We have deployed a lot of sensors, in situ sensors in the pilot places. So we can display the situation of the road through the exploitation of sensors, but we can also monitor the flight of UAV during the collection of data. This is from the information management system that we can task the UAV when an event occurs. So we have two important end users in the project. One is Acciona from Spain. So we are doing the trials in a segment of the motorway 2 that is from Madrid to Guadalajara. So we have these detailed pictures that allow the end user to see everything they want to see, raw data or exploited data, but also the monitoring of mission if there is a need to retask. Next slide, please. So we have also in Spain another type of inspection for maintenance. This is a slope or in the same motorway that is reinforced, but it's sliding slowly. So the UAV needs to monitor from time to time this slope, just to be sure that we don't have a risk of a big landslide on this slope. So in this case, there was two models, one with LiDAR and one with photogrammetry that was done, and the UAV can inspect from time to time the situation of the slope. Next slide, please. So it's just another picture of this slope. So it's photogrammetry reconstruction, just to have precise data about the position of each one of the markers. Next slide, please. So these are the type of data that we want to detect from a macroscopical point of view, that can be detected also by fixed wing. So we have elements on the road like potholes, like we can also want to detect the ice or these kind of things. We have also the flood, we have fire, we have snow, etc. So all these macro events needs to be interpreted in a very different way from the microscopical event like cracks and so on. It's more to put an event in one place than to measure, because the measurement after will be done by another type of UAV or by human. Is just to have the capability on all the motorway segment to detect event that can present a threat for the circulation and for all the flows that we have in accidents and so on. So it's a multi-hazard detection that has been predicted. We can also compare the reality of the event with the prediction. Next slide, please. So it's we have a final thing that was not dealt with in Nairobi, which is the rust. So we have installed rust sensors, and by image analysis, we have another pilot use case, which is the analysis of the evolution of the rust. But as you know, it's not a real-time thing. So it's more in the maintenance capabilities than in the operation of the road. Next slide, please. So road deterioration is another example that we have done. It's especially important in both of the cases because in Acciona, the motorways is going into the mountains, so we have a lot of events of ice, of snow, and so on. So deterioration, and also in the Greek use cases in the north of Greece, it's in Mestovo, so it's a region that is subject to high to icing and to snow. Next slide, please. And finally, in terms of detection, we have the exploitation of satellite in non-use, non-cover, but we can also do it with the UAVs because priority of the end users is also to monitor the vegetation growth in order to identify points that could be endangered by trees or high vegetation. Next slides, please.
Okay, that's all, Philippe.
Okay.
Okay, so thank you very much for your presentation. It was very interesting, and it's an example of how important it is to give continuity to research and development funds in different European programs, and how important are lessons learned in previous European projects, for example, Aerocam. So thank you very much, Philippe. I will see you again in a few minutes in another domain.
Unfortunately for you.
Thank you for being very active. So now is the turn to the last project in this domain, Omicron. Omicron is leading by Cemosa. Cemosa is a Spanish company specialized in engineering, service, and quality control in the construction field. Jose Solis is the project manager of the project. So Jose, I give you the floor. Thank you very much.
Thank you very much to you for inviting us to this very interesting workshop. So as you mentioned, my name is Jose Solis and I work for Cemosa, which is a civil engineering company based in the south of Spain. I am the project coordinator of Omicron, which is a project which is heavily related to this robotics and artificial intelligence workshop focused on inspection and maintenance, mainly on roads. In this presentation, I would like to briefly present the project, going through it in a nutshell, presenting the project concept, and then going through three work streams which are very much related to the workshop of piloting today, which are advanced inspection technologies, robotic inspection technologies, and road personnel support. Finally, I will go through Omicron's intelligent platform where everything will be integrated. And finally, I will talk about the demonstration and the final impact of the project. So as you can see in the slide, our consortium, we are a team of 16 members with from 7 different European countries. We are an experienced and multidisciplinary team with a highly diverse skill set. The project is funded under the Horizon 2020 umbrella, and it has a duration of 42 months. We just started, this project started on May 2021. So we are in month 2, and this is why I will be presenting the technologies that we will be developing throughout the project. As I mentioned, Themosa is the project coordinator, and this is the project officer belongs to CINEA. And we give a big emphasis on the demonstration of the technologies, as we have 4 technical demonstrators for specific technologies and 1 final demonstrator at TRL 7. So we are aiming for high TRL levels. So the overall objective of the project is to develop an intelligent asset management platform for roads in order to achieve the European goals of enhancing construction, maintenance, renewal, and upgrade of the European road network. We have the objective of working from previous European developments in order to implement automation and digitalization technologies for road infrastructures, including artificial reality or virtual and augmented reality platforms. We will be developing robotization of technologies for emergency and ordinary interventions, and also robotic developments for extraordinary interventions in roads. We will also be developing a modular design for modular designs using prefabricates and ITS systems for the stakeholders of the roadway sector. And as I said, our final TRL demonstration will be at TRL 7. So first of all, I would like to go very briefly through Omicron's concept, which is basically based in 4 pillars. The first pillar is related to digital inspection, where Omicron will be developing UAV and terrestrial inspection vehicles for the inspection of road infrastructures, in order to provide further information for both road users and road personnel. And all of these will be enhanced and interconnected by CITS systems and enhanced V2X communications. The second pillar of the project is the development of a BIM-oriented road digital twin, which will both include information from already existing systems, and also the information from the digital inspections based on pillar 1. The road digital twin will be linked to a decision support tool whose objective will be to use artificial intelligence technologies in order to provide optimized intervention schemes for road operators. And the final pillar, also heavily connected to the workshop of today, is the development of smart construction and intervention solutions, including a modular robotic platform using virtual reality platform as well, adapted machinery for extraordinary interventions, augmented reality for the support of road personnel, or a modular construction methodology for road overpasses. So, as I said, I would like to go now briefly through 3 work streams, which are very much related to the workshop today on inspection and maintenance. The first one is the development of advanced inspection technologies, where Omicron will be developing enhanced perception units and technologies for the automation and digitalization of road infrastructure maintenance. We will also be developing innovative inspection tools, which will be put on board of dedicated inspection vehicles. And finally, we will also be integrating and deploying V2I communications in already existing CITS systems in order to provide further information to both control centers and road users. The objective is that all the information that will be captured via these technologies will enrich the information required in order to build a proper digital twin for roads, enhancing the inspection and control capabilities of the road operator. In this work stream, the three main outcomes of the project will be an enhanced UAV platform, both including long-range capabilities and multi-UAV inspections, which will be integrated in a management tool for UAV inspections. The second outcome will be an improved inspection vehicle system with a new perception unit and with the capability of automatically compute road indexes, including IRI, friction or deflection coefficients. And the third outcome will be the development of a maintenance and user support platform using V2X communications. The third work stream will be heavily dependent on robotic intervention technologies. And in this regard, Omicron will develop a modular robotic platform in order to undertake ordinary, emergency, and extraordinary interventions, including, among others, the automated installation of road signals and the cleaning of traffic signals and lighting. Regarding emergency interventions, the modular platform will be able to perform automated installation and replacement of safety barriers. And finally, regarding extraordinary interventions, the modular platform will be able to perform removal of horizontal markings using laser systems and the sealing of pavement cracks. Furthermore, Omicron will develop a decision support system for surface pavement layer rehabilitation and maintenance with the objective of providing more information about the pavement procedure to both the operators and the coordinators of the actions. As I said, the last work stream I would like to talk about is the virtual reality and augmented reality platforms that will be developed in Omicron. First of all, Omicron will develop a web-based virtual reality platform for the teleoperation of some of the robotic resources that have been presented in the previous slides. And this will be formed by constructing a virtual environment using data from various sources, such as on-site sensors, and including a capability to remotely control the robotic resources that have been presented earlier. Omicron will also develop an augmented reality tool that will support field road workers, providing information from the V2X communication system that will be developed in the project, and also improving workers' awareness of their surrounding environment, providing more information such as weather, traffic, or disruptions in the roadway. And finally, as I said, all of these technologies will be integrated in a final road asset management platform, which will integrate all these technologies, including, first of all, the inspection technologies, which will provide information regarding the whole roadway state. This information will be fed into the digital twin for organization and visualization purposes. And the digital twin will be connected to a decision support system in order to plan road interventions optimally. These interventions will then be able to be undertaken using the smart intervention technologies that have been presented throughout this presentation, making use also of the V2X platforms for road users and road operators, and making also use of the augmented reality and virtual reality tools. The demonstration in Omicron will again be threefold. It will be divided into 3 stages. The first stage will be focused on TRL 4 to 5 testing, in which, for instance, we will be making use of the Atlas facilities provided by FADA-CATEC in order to perform this test on the UAV technologies that will be developed in the project. Stage 2 will be the testing at TRLs 5 to 7, including a virtual demonstration of the modular methodology for bridge underpasses, and also 3 technical demonstrators in order to test specific technologies, including the inspection technologies in Madrid, the pavement rehabilitation technologies in Seville, and the crack sealing technologies in Valencia. This will finally lead to the stage 3 of demonstration at TRL 7, which will be performed at the A24 in Italy, where the robotics, drones, digital twin, and decision support tool will be tested. And finally, I arrived to our conclusion, which is the impact of the project, which is based on these 4 main KPIs. The first KPI is the decrease in fatal accidents of road users and deployed personnel due to maintenance work, with a target of reducing this by more than 50%. The second target is the decrease in traffic disruptions due to maintenance works, with a target of more than 20% reduction in this case. The third impact KPI will be the reduction of routine maintenance costs by more than 20% using all the technologies in the project. And finally, the last KPI will be the increase of the network capacity via all the enabling technologies developed in the project, increasing this network capacity by more than 20%. This is this briefly what we wanted to present today regarding Omicron in this workshop. Thank you very much for your attention. We will be very happy to answer any questions via the chat or via email if you prefer to.
Okay, thank you, Jose, for your participation. As you have already commented, the project has just started, so we look forward to discover and see the first result of Omicron in the future.
Thank you.
Okay. Now we are going to change to another domain, oil and gas sector, and in this case we are going to present a high flyer. High flyer is leading by the University of Oulu in Finland, and Johan will be the speaker to this project. So
thank you inviting me to be part of this workshop. And I'm Johan Röning from University of Oulu. I have a professorship on embedded systems, and today I would like to share you information about High Flyer project, where we are doing an inspection in oil and gas industry. And for the reason of good voice quality, I will stop my video so that you can perhaps enjoy more my voice. So in the petrochemical facilities, there are tens of even hundreds of kilometers of pipes, and they are attacked by the atmospheric substances but also corrosive liquids and other stuff is transported through these pipes, which means that they can be heavily corrosive, and you have to inspect them once in a while. So ultrasonic thickness measurements is done to eliminate the risks that the pipe would broke during the operation, which might cause a big catastrophic event. This is quite a challenging operation. It is done by human beings, and it is dangerous, also costly in that way that you need to make a lot of scaffolding so that you can do it. And surely there is always an element of human error which can happen. So we got an idea to eliminate these errors and do the inspection using robotic devices. We have very talented consortium on this approach. So two universities, University of Oulu and University of Sevilla. As an end customers, we have Chevron and Total. Then we have also as a research facility in Italy, Create, who is especially developing the robotic arm and controlling of that part. And from Spanish side, we have also Fadacate as a consortium partner. Then we have two companies, Dassault, who is providing actually the ultrasonic measuring elements also for humans, and from Switzerland, General Electric Inspection Robotics. Our approach is that we combine a flying robot and a crawling robot. And the idea is that using this approach, we can reduce inspection costs and at the same time improve the safety of the measurement. To do this, we need surely a human involvement. So we have a ground station which will support the operation of the flying unit. With this ground station, you can recharge the batteries of the flying unit, and you will have also interface for human operator to follow what is happening, and in some occasions also communicate with the system and help it partially during the operation. Most of the time, the operation will be pretty much autonomous and support the human operator. In this project, we are building two kind of prototypes of hybrid aerial robot. We have a hybrid mobile robot, HMR, and hybrid robot with arm, HR. We are looking forward to inspect magnetic pipes. So we need a system which can do the stabilization on pipe and then do the inspection. With this HMR, we are using an approach where we have a satellite robot which can move around then when the landing has happened. On hybrid robot with an arm, it can be used also on non-magnetic pipes. The stabilization is arranged using the arm and batteries, wheel friction and even the stabilizing rotors. And this unit can then move along the pipe, and using its lightweight arm, it can reach also some more complicated parts of pipe sections. So first, a little bit about the MR robot. So it can take off, fly, and land and deploy the UT robot on a pipe to perform the inspection required by the end user. And as I said, this system is focused on magnetic pipes inspection. So it has an aerial vehicle, robot base or lander, and then the satellite vehicle to do the ultrasonic inspection. Here is a little bit better picture about the wheel platform for pipe inspection. It has permanent magnetic wheels, and it can do then the measurement in a good way. Here are some preliminary tests and integrations which are related to the control system, how to do the perception and find the pipe and do the landing. And also there are quite many of pipes and also other obstacles, so you have to be able to detect them and also avoid them so that no harm or collision will happen. Surely we have had a couple rounds of integrations and specification designing, and now we are doing the final round of this, and hopefully the COVID situation will ease and we can do further site visits. During the last year and a half, we are not able to do the site visit, so we have had to work at the laboratory environment. Then the other prototype will be a robot with arm. So it will be a modular, so it has interchangeable landing gears for different pipes. It's a hybrid. It can fly, crawl, roll, and do the inspection. It has also safety features, so it will have a safety bridge, so it can quickly detach if needed, if there is a gas leak or something like that happening. Here you can see some examples of the first prototypes, and you can also see some publications which have been either on which have been the journals and conferences. Since we have quite wide range of pipes, one challenge is that how we do the landing so that it will softly land and attach to the pipe in a good way. And we have developed some different methods to do that. And here you can see some experiment and tests which we have done. Also, there are different approaches how to move along the pipes. Surely we need quite good perception, and we need to do that in real time so that we can actively navigate and try and find the right places to do this. We are using some passive sensors, but also some active censoring elements to create occupancy mapping when it is needed. Here are some experiments which is done in CREAT, where the robot will land on a pipe, and this has the arm on board, and you can shortly see how the arm is also operating. So here you can see the arm operations. So arm can then move along the pipe and do the measurements. So thank you for your attention. If you need any further information, you can either contact me or follow our web pages to find what kind of results we have achieved. So from my side, thank you, and I'm ready to answer any questions if you have any.
Thank you very much, Johan. Thanks to be in the end of the project. The video were very interesting, give us an idea of the result of this hybrid air and ground solutions. So thank you very much, and we are very proud to about the speed of this workshop. We are complying the schedule, and now I will give the floor again to Philippe. Now in another domain.
Yeah, I'm here.
Okay, Philippe, I will.
If you are fed up with me, then you can tell it.
Yeah, I will share again your presentation.
Okay.
Just give me 1 second. Okay. Now I will share in this slide. So I give you the floor. Can you see the screen, Philippe?
Yeah, it's okay.
Okay.
Okay, no problem. So 5D Aerosafe project is also in enhancing the communication and transport capability, but it's innovating in the sense that we want to fly UAV in airport. So as you can imagine, a lot of people are scared about the possible conflict between the normal traffic and the UAV traffic. So it's something that is not only around the use of UAV for the inspection and maintenance, but it's also a project that is also based to operate UAV in an airport. So it's a negotiation and of course coordination between air traffic management and UAV traffic management, which has been dealt with CESAR project in many projects. Next slide, please.
Can you see?
It's not.
I think I have a problem. I will share again the presentation,
okay.
because I don't know why I cannot. Okay. Here. I hope.
Okay, so the project was selected and started 1 year ago. The name means that we are developing 5 services of drone for airports and waterports, and we have 10 partners among them. I would like to mention people involved in UTM like AirMap, well known, Also the Air Force, the Polish Air Force that are bringing a lot of UAV. We are working, of course, under the control of Eurocontrol. We have the University of Vicomtech dealing with the image processing. And we have two very important end users for the airports. The first one is Ferrovial from Spain. So that Ferrovial are, let's say, involved in the management of many important airports, including Heathrow, where we plan to do the final demonstration. And we have waterways from Greece, because we are also dealing with the aspects of waterways. It means the between the islands in Greece, there is a development of a lot of waterways, and the problem due to this are a little bit different, because the runway is water, so we have other problems to deal with. Next slide, please. So next slide. So the phase 0, which is a little bit delayed due to the COVID, but nearly completed, is to have the architecture of the system after the end user requirement. After, we will deal with the concept of operation of the system supported by preliminary trials. Mostly in a small airport and in Kirkira, sorry, Corfu, for the waterways. After phase 2, we have the development of the whole system, and finally we will test the whole system integrated in the end of 2023, from the end 2023. Next slide, please. I will not go. I will not be too long on the motivation. As you know, the safety is a very huge problem and very critical problem in the airport. So for the moment, most of this safety inspection are done with cars or manually, so there are a lot of disturbance related to the time and the segregation, the full segregation of the two traffic management. Finally, what the people are requesting is to have a way to inspect quickly the airport and waterways, which are very big infrastructure, a lot of square kilometers. So using cars and people take a lot of time. And the motivation, of course, is to provide services that try to answer this question. Next slide, please. So we have focused on 3 main services. The first one is to inspect the runways and taxiway. You know perfectly well that the runway and taxiway needs to be inspected to find some debris object, FOD we call it, on the runway that could threaten the landing, the takeoff, and of course the circulation of aircraft on the taxiway. So this done with mainly cameras installed on UAVs. So the UAVs can be VTOL for detailed inspection, or can be fixed wing for the inspection of the runway in the first step. So I put it in the other order. Let's say that we are using fixed wing to try to detect events, and after we will launch VTOL in order to characterize this event or this object on the runway taxiway. The second service that we want to bring is the calibration of sensors in airport and water ports. So again, you have a lot of landing aids on airports and water ports, and they need to be inspected regularly. It's done for the moment with real aircraft, so it means that it costs a lot and take more time. So we want to develop a sensor that will be miniaturized and put on the UAV in order to fulfill this role of calibration. These two services, the inspection of runway and taxiways and the calibration of sensors, are related to the safety of the airport. And we have a last service that is the service related to security. So we use the UAV to detect abnormal behavior or abnormal position of people or cars in the airport, but also in the vicinity of the airport, in order to raise alarm of possible threats to the airport or waterports. Next slide, please. So this is more or less the architecture of the system. I will not describe it, of course, but from end to end, first we have the new sensors. So the new sensor that will be miniaturized to put on the UAV. We have several UAS, main system coming with their own GCS that will be integrated around the generic ground control station. So this is for the management of the swarm of UAV. This generic ground control station, which is more a tasking capability than a piloting capability, is linked to the platform, the 5D aerospace platform with the services integrated. So this platform has two main objectives. One objective is UTM. So we know what will be the flights of the UAV for the task that we want to do in 5D aerosafe. And the UTM platform will have a status, a real-time status of UAV missions. And the second objective of the platform is to define the mission from a request that are given by the ATM, so the tower, in fact. So the air traffic management will task the UAV for inspection and maintenance. The platform, 5D aerosafe platform, will prepare the mission and send the tasking order to the generic ground control station and specific ground control station, so they can plan the flight to be operated automatically. And finally, on the right part, you have the ATM, which is air traffic management. So it's the tower that manages the platform, all the operation on the platform, and they will interact with the UAV operation all the time. Next slide, please. So the main challenge, I told you before, so it's the main challenge is to implement this this drone system in a place where safety and traffic is of utmost importance. So we don't want to have any accident between the UAV and planes, of course. For the moment, we are operating segregation, but it will come more and more to a flexible situation where we can manage in near real time, comparing the traffic, the air traffic, and the UAV traffic that we have. For inspection and maintenance, it can be done while the airport is closed, but in terms of security, you can imagine that it has to be done 24 hours a day. Safety, calibration, safety, and security are the main words. Next slide, please. So this I told you. So next slide. So what the result that we want to have describe the 5 poles of 5D aerospace. So the calibration, operation and inspection of waterways. Aircraft inspection is not really in the project for the moment, but of course, as you can imagine, it's something that could be done also quite easily, especially when there are problems related to icing, to snow, whatever. Runway and taxiway inspection, and security on the airport infrastructure. Next slide, please. So means that we have, as I described in the architecture, 3 focal points on the system, 3 main points. So the generic ground control station manages all the flights of the UAV. We have the platform, the system platform that manage the UAV mission in coordination with ATM, and we have this seamless UTM-ATM coordination for non-segregated airspace. Next slide. So the use case that we have is, of course, one part of the use case are at airports and airport infrastructure. So as said before, we start with a small regional airport, and we hope we can finish in Heathrow. And the second one is about water airport in Corfu. The specificity of this Corfu waterways is, of course, close to another airport. So there is also the coordination between the ATM in the airport and the ATM in Corfu. Next slide, please. It's finished. So I kept it on time.
Yeah. Thank you very much, Philippe. 5D Aerosafe is the only one project in this airport domain. Thank you very much for your double presentation. And if you can answer any question in the question and answer tab, it would be great.
My name is Sergio Gonzalez. I'm the head of testing on advanced processes unit in CATEC. Well, the project is called Durable. The name is coming from the maintenance, drones and robots to enhance renewable energy system in the Atlantic area. First, let me summarize what is the Interreg Atlantic Area Program. It's an European program for promoting transnational cooperation among Atlantic regions, European countries. So basically it's France, Ireland, Portugal, Spain and United Kingdom. The Durable project is framed in the priority 2 of this program, devoted to fostering renewable energies and energy efficiency. The total budget of the project is around 3.9 million euros. The project duration is between April of 2019 and September of 2022. It will be delayed 6 months because of the COVID extension. Sorry. Yeah. Well, the main goal of the project is to transfer technologies that we have detected developed already in the aerospace and robotic industries to cover necessities within the renewable energies facilities for the operation and maintenance activities. So the Durable will help to overcome one of the main barriers, which is related to the cost of operation and maintenance activities in the renewable sector. The project is formed by 13 research and companies centers along the Atlantic area, from the Ireland through United Kingdom, France, and Portugal and Spain. Is led by Estia, which is a university located in Bayonne, in south of France, and FATACATEC is collaborating in the project. Well, this is more or less the work package structure. There are a couple of non-technical work packages devoted to communication activities led by the cluster of energy from the Basque Country in Spain. The capitalization work package is led by Estia University. And then we have 4 technical work packages that I will explain now. The work package 4 is devoted to find or mapping the necessities and the technologies developed in the aerospace sector and the necessity coming from the energy sector, and try to match the necessities with the technologies developed. The work package 5 is devoted to the adaptation for the navigation and surveillance, and the work package 6 is the objective is the adaptation for the repair task mainly. There will be a final work package 7 for the demonstration of the technologies that we have transferred from different industry to the sectors of renewable energies. This is the existing technology that we have detected or we have proposed within the durable program for covering the necessities of the renewable energies sector for operations and maintenance. From the predictive and preventive point of view, of course, the drones platforms is developed, and the ground systems, and also entity inspection, not only without contact, that can be, for instance, infrared thermography, but also with contact, like for instance, ultrasonic or eddy current. Now, from the corrective or repair point of view, we included the additive manufacturing technologies and composite repair. The final demonstration will be in two lines. One is devoted to the wind farms, windmill farms, and the other one is in the solar sector. What is CATEC in this project contributing? We are developing technologies for autonomous aerial inspection without contact, including visual, of course, but also infrared thermography mainly for solar farms or solar plants, and also we are developing partial autonomous drone inspection with contact, mainly through ultrasonic testing. From the navigation side, we have been working on developing mainly algorithms and autonomous navigation functionalities for detection and avoidance of obstacles, tracking of mobile objects, 3D mapping, etc. From the point of the infrared thermography monitoring, we have been working already in industrial relevant environment, in concentrated solar power plants, mainly parabolic plants, detecting loss of vacuum in heat pipes, also loss of isolation in tanks. With contact technologies, we have been working with ultrasonic mainly, adapting technologies that are being used in aerospace industry, like this example is a phase array probe for ultrasonic evaluation. We have been working on adapting the protocols of inspecting parts to a new kind of wind blades material, and working with trying to detect not only thicknesses but also impact on or any inner flows on that kind of material. What is coming in the project from our side is we are adapting mechanisms and platforms to be able to perform contact inspections through ultrasonics, so we can transfer the protocols that we have been developing in labs by manual inspection to the drones on wind blades. We are designing platforms to be adapted to the probes that we need for the inspection of windmills. We'll develop also autonomous and collaborative drones with georeference possibilities for solar wind plant maintenance. I think this is more or less a summary of the project. This is my contact, and I don't know, anything you may ask me, I will place to answer.
Thank you very much, Sergio, for your presentation. I think we don't have any questions, so we can move to the last project of this domain, which is Atlantis. So thank you very much, Sergio.
Thank you. Thank you.
Okay, Atlantis will be presented by João Marques from the Institute of System Computer Technology and Science in Portugal. Joao, I give you the floor.
Yeah, thank you. Good afternoon.
Good afternoon.
Just share the screen. Can you all see my screen?
Yeah, perfect.
Okay, so I will be presenting the Atlantis project, which is the Atlantic testing platform for maritime robotics, which will hopefully enable a new era for robotic-based O&M. So the consortium for this project consists of 10 partners from 6 countries, and they range from academia to technology providers, end users, and regulators. And the project is under the umbrella of the Horizon 2020 program. The time frame for the project is 36 months. So the inspection of offshore assets, and particularly offshore wind farms, is highly relevant. So in the Atlantis, the aim is to enable robotic technologies for the inspection for the inspection of the structures in order to increase safety, security of operations, optimize resources, assess the useful life of infrastructures, ensure environmental protection, and reduce downtime of these assets during the operations. So we consider 4 particular areas for this project. First one being access to industry-led demonstrators, which will we aim to have open access to real-world testing. The automated vehicles for safety, particularly the driving in underwater, which can be hazardous sometimes. Improving tools for inspection and maintenance, which will allow for repeatability and digitalization of some of the tasks, and to promote robotic platforms in supply chains. And by this we mean to have actual robotic technology be used by end users and ensure that the best practices are in place. To improve access to industry-led demonstrators, we propose the Atlantis Test Center. So this will be a facility built to allow the validation and demonstration of robotic technologies, which could effectively improve the rollout of technology for end users by allowing cost-efficient validations and demonstrations. And here you can see a short 3D visualization of part of what the test center would look like. So the test center will be a large-scale pilot for demonstration of the use of robotics. It will be installed in Viana do Castelo in Portugal, which will allow the demonstration of the use of robotics in industry-oriented showcases that were built from actual user needs. It will also allow for the validation of these technologies in a near-real environment or in a real offshore wind farm, which is the wind float Atlantic. So the test center will be divided in these 2 components, as you can see here on the image, the coastal test beds and the offshore test beds. The coastal test bed will be focused on lower TRL validation, while for the offshore test bed, it will be possible to showcase and demonstrate high TRL technologies ready for deployment in a real environment, which in this case is the Atlantic Ocean. I have here a short video showing the concept. I'm not sure if you can hear it. Can you hear the sound of the video?
Yes, we can hear it.
Yes, we can hear it.
Okay, so as I mentioned before, in Atlantis, we considered a set of industry-oriented showcases, which in particular we considered 4 showcases, which we divided each into 2 scenarios. So a total of 8 different scenarios. So in the first showcase, we're focusing on turbine inspection and maintenance, and we divided into 2 scenarios, 1 and 2, which consists the inspection of the blades and tower, and inspection, maintenance, and repair of the transition piece or floating structure, depending on whether you have a floating windmill or a monopile. The second showcase is focused on export and array cables, which is divided into repair of underwater floating cable protections systems and the monitoring over extended periods of time of these cables. The third showcase covers scour protection and foundation protection. So it's focused on close range inspection of foundations and monitoring of scour protection interventions. And lastly, the last showcase is focused on logistics and support. So the scenarios we considered are operations, O&M operations supported by crewless vessels, and the optimization of robotic-based operations. We already have a video showcasing a potential method, how robotics can bring new methodology for the first scenario. If you want to know more, the video is available on our YouTube channel, and you can also follow us on LinkedIn, where we have regular updates on the project. So still on access to industry-led demonstrators, we also have available Tech for Sea services, which is another project which will help with open sea experiments for, in the case of the offshore test beds, provide technical support, and also have allow access to equipment and vessels necessary for this type of experiments. So moving to automatic vehicles for safety, we are working with a multitude of systems. We have here an autonomous surface vehicle that is focused on 3D multi-domain mapping, and the idea is to have real-time monitoring and inspection of offshore infrastructures, which you can see being performed here in the images. We also have access to autonomous underwater vehicles. These focus more on visual inspections in open and confined spaces. More than just inspections, we're also interested in actual interventions. So we are working with underwater vehicles capable of that. We have one here, which has robotic arms, which allow interaction with the structures, and the use of different end effectors in these arms allows for different tasks to be completed. So, for example, here we have, for example, the case of the scenario 2 that we talked about before, the inspection and maintenance of the transition piece. You have the robot attach itself to the underwater structure and use the other arm to perform the cleaning of the structure. Once the cleaning is performed, detaches itself, changes end effectors, and approaches again to perform an inspection. In this case, a cathodic protection of the surface. As I mentioned before, long-term deployment is also one thing to be considered here. So we are also working on a docking station that will allow the charging of robots underwater. This will allow for the robots to be deployed for long periods of time and perform inspections at regular intervals or as required based on the situation. For the areas above water, so particularly the blades and tower, we are working as well with unmanned aerial vehicles, and this is focused mostly on navigation and visual and thermographic inspections for defects of these structures. In terms of tools, improved tools for inspection and maintenance, We are working on new underwater imaging technologies capable of performing 3D reconstruction and with sub-centimeter accuracy for the reconstruction. And these are to be used in inspection to obtain better details of the structures and the environment. As you can see here, you have the results of some 3D reconstruction. We are also working with underwater manipulation. In particular, we are working on the planning and grasping actions of a robotic arm, collision-free planning, so that robots can move around and interact with the environment without colliding with any other elements. And the idea here is to use the results to improve robotic underwater interactions during interventions. We are working as well to coordinate all of this. We're working in a supervisory control center, which will allow to remotely control and supervise the operations. The idea is that this will be built in the coastal test center, coastal test bed, and we'll be able to monitor operations in both test beds. So it will, like I said, we'll be able to define, monitor and supervise operations. It will allow as well to retrieve and present collected data from the systems. It will also provide an interoperability layer that will allow seamless operation of heterogeneous vehicles and unified commands from multi-agent planning and data retrieval, so that everything is into a single component and it's unified properly. Finally, we look into the promotion of robotic platforms in supply chains, and this will be achieved through the use of through the test center by allowing demonstration validations of a range of different TRL levels, which will provide potential streamline from technology developers, from research and development to potential end users. The test center will also allow technologies to be demonstrated in controlled but representative environments, and is open to all stakeholders in order to increase the adherence to robotic solutions for inspection, maintenance, and repair activities. To conclude, the Atlantis will allow appropriate testing, validation, and demonstration, which can provide a safe way to try new prototypes, de-risk new robotic platforms for potential end users, enable new institutions to obtain field experience and build credibility as well, and de-risk future activity planning by assessing the resources and times required in order to reduce downtime of actual structures. This concludes my presentation. Thank you very much.
Hello, João. Thank you very much for your presentation. I still think we have some time, so there is one question on the chat that maybe you can answer directly, since we have still some minutes. So Jorge Gamarra asked, why are not you using EMAT sensor for thickness measurements? With this technology, we'll avoid the cleaning process.
Well, possibly, but the problem is that, I mean, I just gave a single example of a single structure. There are other problems. So in other cases, so marine growth is it's a big problem in this area, and not just in terms of the surfaces that we have to inspect, but also, for example, when dealing with protection cable, the cables, the array cables, and they need to thoroughly be cleaned in order to assess their structural integrity as well. So this might be a possibility for some cases, but maybe not all.
Okay. I hope, Jorge, that it was a good answer for you. I don't know if anyone has any other questions. Yes, he said yes. Okay, thank you. So, Joao, thank you for your participation. With this, we conclude the session of the project related to renewable energy infrastructure. And also would like to thank Macarena for supporting the project, and I will continue with the last session. Macarena, thank you very much. And Joao, thank you very much for your participation.
Thank you.
So now let's go to the last part of the workshop. I'm very glad that we're still almost everybody is online. So thank you very much for being the whole workshop. I think it has been a very interesting workshop. Up to now, all the projects have been technological projects that are developing robotic and artificial intelligence solutions for inspection maintenance. And now we are moving to a different type of projects, the one that are promoting robotics in inspection maintenance application. And we will start with Marit Sandelin from Spring Robotics. Hello,
yes,
good afternoon.
hello.
Hello. So she's going to present RIMA network. It's a network of digital innovation hubs focused on robotics applied to inspection and maintenance. So it really fits, and one of the co-organizers of the workshop. So Marit, the floor is yours. Thank you.
Thank you. I hope my screen is showing nicely.
Yes, we can see it.
Okay, great. So RIMA, what is RIMA? We started in the beginning of 2019, and we are a 4-year EU project with a budget of 60 million euros, which we are distributing and have distributed already some of that to SMEs with 2 different open calls. So our idea is not to do any technology innovation, but rather help the digital innovation hubs improve their services, but also at the same time build a network of any companies who are working with robotics in inspection and maintenance. So we have both the services offered by the DIHs, but we also would like then to have the whole value chain together in the network to promote robotics in inspection and maintenance. So we are 13 digital innovation hubs across Europe, but also then industrial associations. So we are from Greece, Spain, and Italy up to Norway and Finland. We have also the industry associations are, for example, Water Europe or Sprint Robotics that I present to Foratom for the nuclear sector, and I believe some others. And we cover 6 different industries. So we have the energy, oil and gas and chemical, nuclear, transport, cargo and mobility, and water supply and sanitation, and urban and suburban transport routes. So all these 6 different industries are part of the open calls that we have in the RIMA network, but also we are then focusing more on these. So basically our vision is to be an actor of reinforcement of European leadership in inspection and robotics. So what we want to do is we want to connect the whole value chain across in these 6 different industries that work with inspection and maintenance robotics and bring them under one roof into the RIMA network, and then foster and collaborate in this RIMA network and all this to get the uptake of robotics, but also then the innovation of robotics, bring them forward. So as mentioned, so we want to connect, so not only research and technology providers, but also all the end users. So we also want the asset owners and asset operators into the network, because they are the ones who have the market intelligence to tell us what exactly is needed and what they are focusing on. We also want to support the end users to share their challenges, but we want to support the SMEs to commercialize their solutions, because it is extremely difficult for a small company to have access to a big end user company and then share what they're working on or what kind of solutions they have. But we also then want to provide some education and training. So this will happen through the DIH DIHs this training. And just to let you know, we are starting on the trainings in September. So if you are interested, then keep an eye out on our website and our community tool. So how we plan to do and how we plan to work in this network is, well, training, as I mentioned, anything to do with networking, collaboration, and knowledge sharing. So we have started with in March with domain-specific webinars. We've had nuclear, water sector, clean energy was in May, and now tomorrow we have an oil and gas and chemical webinar coming up. So I will share the link later with you if you are interested. We also plan to have different seminars. So we have had one online seminar last September, and I believe depending on the COVID situation, I believe this year we will at least continue with online seminars. And as soon as possible to have any face-to-face interactions, we are trying to have local demonstration days where we will then invite different SMEs or research organizations to demonstrate their technologies. We also provide access to expertise and test facilities. So the different DIHs have different test facilities that would be available for rent. We also want to provide SMEs a way to share and market your products and services, because it's all about the sharing what you are working on. And then, of course, then distribute the market knowledge, and then all interaction that can be done between different companies. Just a short picture of the whole value chain, which we mean to for us means not only digital innovation hubs, but any universities or research organizations, technology companies, end users, service providers, but also then industry organizations. So as mentioned, we had 2 open calls, just a very short video to show. All right. So as mentioned, we had 2 open calls. So our first open call ended in the end of 2019. And with this first open call, we funded 19 different projects within the 6 different industries. So for the first open call, we had 2 types of experiments. So we had technology transfer experiments, which were longer and they received a little bit more money. And we also had shorter technology demonstrators with a little bit less money. And overall, we received 121 applications from quite all over Europe, and we the majority of them were for oil and gas and energy. So very good projects. So here's some examples of what we funded for different industries. So we had, for example, an automatic defect detection system for the solar panels. We have underwater nuclear decommissioning robots for cracks on the roads, ATEX drone, currently still ongoing this project. Then we had a drone with indoor 3D localization and mapping properties, and then also airport payment inspections. So if you are interested in these projects, then I can easily share more information with you, but also you can find all information on our website. And yeah, here's the website where you can find it. For the second open call, We simplified the process a little bit, so we only had one type of experiment that can run up to 14 months, and then the funding can be only up to 150,000 euros. So in addition to the funding, we always provide 2 digital innovation hubs that will provide mentoring for these projects. So for this second open call, we received 154 applications. And I think we reached Europe quite well, because there were only 2 countries in Europe we didn't receive an application from, and the other one was Malta. And if I remember right, the other one was Lithuania. And for this one, as we simplified the project a bit, we will be able to fund 31 projects within the 6 different industries. So we just currently had the jury day, and I believe the communication to the projects who have been accepted will be starting soon. And then also, once we have all the projects have been informed and the project will start, we'll have more information available on the website and the community tool. Just wanted to share, as I said before, we have this domain-specific webinar. So tomorrow at 2:30 Central European Summertime, we have the oil and gas and chemical one. So we have speakers from Total Energies, Energy, Robotics, Sonomatics, Anybotics, and Lucid Software. And we will also have presentations from the 3 projects that were selected for the oil and gas domain. And after the summer holidays, we will continue the domain-specific webinars. So we will go into the transport hubs and infrastructures, and then also continue then the discussion within the water and clean energy sectors, and also oil and gas. So please take a look at those. And if you're interested, just sign up. These are free and open to everyone. So the one thing we would like to do is invite you to join the RIMA network. So the RIMA network is free. So only thing you need to do is sign up for the community tool, which the address is seen here. So it's open to anyone who is working with or interested in inspection and maintenance and robotics. So we will share all recordings from our domain-specific webinars, and also share any information or research papers or anything that comes from the RIMA project in this community tool. So I would definitely welcome you to join, and then also you can ask questions or share product services that you are working on. So that is very welcomed. And yeah, that's it. So just follow us on our LinkedIn, Twitter, website, and then join the RIMA community tool to work with us. Thank you.
Thank you, Marit. It was very good to have this presentation about the RIMA network. I think it's a very nice umbrella for all the ecosystem of people working on inspection, maintenance, and robotics. So we are surprisingly good on time. Okay, I don't know if anyone in the audience will have any questions or something like that. Yeah, well, this okay. Let's say that. Okay, there's one comment for you, Marit, later, but maybe you can see later in the chat.
Okay, I will take a look at that and make sure it works.
So basically, I think that it could be. I think, in my opinion, that the RIMA network could be interesting umbrella in order to increase the cooperation between all these Horizon 2020 projects. So I guess that it could be nice to explore possible ideas to maybe organize in the future a workshop on best practices or lesson learned and things like that. I think these kind of things could be very nice, including maybe the projects that the RIMA network is funded, not only the large project, but also these specialized smaller projects. So I think that could be a good thing that maybe we can explore in the next year.
Yes, we have the Digital Innovation Hub best practices are already on the website, and then we are currently gathering the success stories from the first open call projects.
Okay, oh, that's very nice. Okay, so Marit, thank you very much for your time and for presenting RIMA Network. We'll go to the next project. It's a metrics project that will be presented by Hans Delaborde from LNE. Hello, good afternoon.
Hello, Antidio. Hi.
Hi, how are you doing? So metrics is a particular project in the sense that it's a project about organizing competitions, okay, robotic competition for 4 different domains, and one of the domain is inspection maintenance. So that's why you're here. So I think this is also a very good way of promoting and also promoting robotics inspection maintenance, and not only for promotion, also for benchmarking, you know, in order to see what is the technology at which level. So Hans, thank you very much again for your time, and the floor is yours.
Okay, thank you. I'm going to share my screen, the whole screen. I think it's going to be better.
Yep, perfect.
Here we go. Okay, so thank you for this introduction, Antidio. So I'm Agnès Delaborde from LNE in France, and we're going to talk a bit about the H2020 project metrics that started at the beginning of last year. So the initial statement in the project was that on the one side, we've got suppliers of AI solutions and robotics. And on the other side, we've got people who would like to use these solutions. In between, we understand that there is a need for trustworthiness. For example, if you want to buy or use such devices, you need to be, to have something reliable. So there's a strong need for a proper evaluation of those systems. The idea of metrics is to organize competitions, as Antidio said, and we want to follow several objectives. So first of all, concerning the domains of application, we've got inspection and maintenance of infrastructures, obviously. And we also focus on agri-food solutions and also solutions for healthcare and agile production. So we've got 4 separate domains, and our objective here is to design a common methodology for the evaluation. I'm going to speak a bit more about that. Also, we want to focus on the robotics aspect, but also on the artificial intelligence aspect as well. And since, doing research, it's interesting in itself, but we need as well to take into account the needs of all the external stakeholders, including industry. About the project and, the community around the project, we are 17 countries in Europe. We've got an advisory board made up of, in particular, the NIST in the United States and the Queensland University of Technology in Australia. Plus, we've got a robotics stakeholder board made up of 10 members all around Europe. In the way we organize the competition, all the competitions in all the 4 domains, in all cases, we start with the preparation of an evaluation plan, what we want to observe, what we want to assess, what type of performance we want to explore and to be able to measure. And the first step, the first year of the project was dedicated to doing a dry run competition. What we call a dry run, it means that we are not going to evaluate solutions from the participants. We're going to make sure that the evaluation procedure is okay, that indeed it works. And after that, we're going to organize a first campaign, 1 year, and the last year of the project is going to be the second campaign. As you understood, I guess the campaigns, the competitions, in fact, they're addressed to external participants from almost everywhere. Anyone can take part to that. Concerning the competitions themselves, as I said, there is one side, well, on one side, we're all interested in robotics, and on the other side, we're interested in artificial intelligence system. So we organize first a field for each domain. Obviously, we organized first a field campaign. So here we test the robotic device on the field or on the physical test bed. And we also organize what we call cascade competition. It means that we take the data emanating from the field campaign and we use them to evaluate several software aspects for robotics. Here we can see this whole process. So on the one side, at the beginning, we always have a field evaluation campaign. We extract data from that. Well, it's raw data. We do, as is usual in AI competitions, we do some labeling of the data. We do data qualification as well. We obtain test data and we use them for the cascade competition. Concerning the elements that we want to evaluate, first we've got the notion of task. So the task benchmarks, they are dedicated to evaluating a general task that the system must achieve. So it's a higher level. For example, here it's the action of fetching a glass of water when asked. So we understand that behind there are many modules that are required. That's why we do this overall evaluation on one side, and we do also evaluation on functionalities. So here, well, a task can be split into several sub aspects of the performing of the task. Concerning the evaluation method for the cascade, for example, here, if it's on computer vision, on the left side, we can see that we acquire some data emanating from the devices, the physical devices. We obtain here images, pictures. We do some labeling, so added the human reference to the ground truth. We do some computation. We design metrics to be able to assess what we want to assess in terms of performance. And obviously, we compare them to, we compare the references to the hypothesis emitted by the softwares. As I said, we deal with the 4 different industrial domains, and naturally, we don't want to evaluate, we don't have to evaluate the same things depending on the application. So here you've got a list of what are the differences between the domains. And naturally, as I said, we want to design a common evaluation methodology. So it doesn't mean that we're going to assess every time the same thing, but we do it in the same spirit, the same methodological spirit. Or for example, repeatability, reproducibility as much as possible. And well, the way of designing properly the metrics, for example, to make sure that we do assess the right level of performance, the right type of performance. So it's competitions. It's open to the general public as well as to research and industry, academia. Well, you can join as participants. As you understood, each year we've got actions. So dry run phase, where we need to involve people, even at their dry run phases. We've got 2 competitions coming in the coming years for each domain. So here I wrote down, for example, if you're interested in joining the inspection and maintenance of infrastructure competition, for example, you can send an email to the organizers of this competition, so Remy at metricsproject.eu. You can also go to our website, metricsproject.eu, naturally, to have some information, well, to keep in touch with us. And we're also interested in getting in contact with sponsors as well. So sponsors, they may come from industry, The objective is to get them involved in the process of the competitions. Naturally, well, it's a win-win situation for everyone. Well, it can be interesting in terms of visibility, since competitions are meant to be public events, and it can be also interesting because the sponsors can help us shape the forms of the competition. So here we put the address, email address, and don't hesitate for any types of question. Well, you get the address at the bottom of the slide, so info@metrixproject.eu for any types of question. You're welcome with that. So I'm done with that. If ever you've got question, and if time allows, I'm okay.
Yes. So thank you very much. Yes, we as I said before, surprisingly, we are well. We're on track. So we have some time for questions. Just to give some more information for the competition that will be virtual for the RAMI competition, inspection and maintenance, will be organized in collaboration or as part of the AEROS competitions. Okay, so if you go to the AEROS webpage, I will put the link later in the chat, you can get all the information about this first robotics and inspection maintenance competition that will be held virtually, but along with AEROS conference. So I don't know if people are getting some questions. If not, Agnes, thank you very much for presenting the project.
Thank you for the invitation, Antonio.
I hope it was interesting for you, and I think it's interesting also to disseminate this kind of project. No, that is not only development of technology, but also ways to promote and also involve students and new people in this domain.
Yes.
Okay. Thank you very much. And I think we can go to the next presentation. So the next presentation is about the Aerotrain project, which is an international training network. It will be presented by Matteo Fumagalli from Electro DTU. Matteo, good afternoon.
Hello, hi Antonio, can you hear me?
Yeah, we can hear you. Can
you see the screen?
Yes, we can see the screen. So this is also a different project. In this case, this international training network. For those of you that you don't know what it's about, it's a team of PhD students that they want to develop the PhD student, and they will be trained on a specific topic, and they will collaborate and they will have a specific. So it's a way to also to create new professionals, Matteo, for this. So now the floor is yours. We are good. So if you extend a little bit more, there's no problem. Okay.
Okay. Thanks. Okay. Hi everyone. Thanks, Antonio, for inviting. It's a pleasure to show our project Aerotrain to this big list of stakeholders in the field. So Aerotrain is, as Antonio was mentioning, it's a Marie Curie project. It's an innovative training network, which has the main goal of filling a skill gap in the industry and also to fill a technological gap. So basically, we do research, or we have 15 PhD students who will do research on aerial robotic technology, and the goal is to develop this technology further for performing inspection on the field. But additionally, we also want to develop the maintenance capability. So we want the UAVs to establish physical contact with the environment and perform active tool operation also. So the project started in January 2021. It has a total budget of 4.1 million euros, and there are 15 organizations involved, 7 academics, 3 RTOs, 2 SMEs, and 3 enterprises. And we will hire a total of 15 PhD students, and the organizations involved in the project will have we are developing right now training to support and push the knowledge of knowledge institutions towards technology development and field operation of this technology. So why Aerotrain? The motivation is, as you have seen already in several other presentations, it's the aging of infrastructure, which require continuous inspection and maintenance. There is also a big market behind it. And finally, also the fact that this type of operations, which are currently mostly done by human, are very unsafe, and they are performed in dangerous environments. So what we want to do is to use aerial robots in order to perform the inspection of the asset, but also maintenance, because we believe that this can be a cost and life saver. However, we have some problems which are mostly related to the fact that the technology itself is very young, and it's not very good yet at using tools and interacting on the environment. The most recent advancements are that on the field are for deploying sensors, but we cannot yet perform operation like a human would do. It is also difficult to autonomously recognize, for instance, a class of damage just from a picture, and the users or those performing inspection, they have to be on the site so that they can objectively classify the damages. And finally, also aerial robots are quite difficult to maneuver. So this requires piloting expertise, and also the fact that we have this new type of technology. So we want to use the drone as a robot. There is not really a system that allows to intuitively use the robot to perform operations on the remotely. And here is one of the biggest questions, which is who knows how to pilot an aerial manipulator? So there is basically, we identified in the proposal phase that there is a competency and a human resource gap that needs to be filled in order to ensure that this technology can be used effectively by the industry. So we cannot rely anymore when we want to deploy this technology on human pilots that are piloting using the remote controller as it is done today. So we need to develop new technologies so that we facilitate the use of this technology on the field for real operation. So in here we develop our research program where we look into key technological gaps that are required in order to unleash the drones as robots. And we look into three main research pillars. One is the drone itself and the drone as a robot itself. So the UAV mounting tools that is able to perform actual physical operation and tasks. Then we are looking into the perception system that is able to, and here it's a lot of AI machine learning involved, that is able to support a remote assessment of the user. So basically we combine the human intelligence and the artificial intelligence and or visualization system, AR, VR, and so, in order to give a feeling to the user that he can trust the technology and the assessment from remote. So it doesn't have to be on site anymore. And finally, when we talk about physically operating, also we want to have the user in the loop again. And here we talk about teleportation, sort of. So we want to have an aerial avatar of the user, of the operator, so that also in this case there is the trust that the operator feels that is doing the operation himself, and it's not left in the hands of a machine only. And we want to bring this technology that right now it's very much at lab level, it's quite low TRL. We want to bring it to some sort of demonstration. So we organize integration weeks, and we organize a grand challenge that will be our pilot demonstrator. And then this was the research program, and around this, we are developing the training. So what we want to do is to develop a training that supports the development of talents, so that that are expert in the inspection and maintenance domain, and in the use and development and implementation and deployment of aerial robotic technologies. So within the training, we train them through research, through 15 research projects, one for each PhD student that will be enrolled in this training program. And each project will address a technological gap that is related to drone technology or related technologies. And around this, we are developing also competence training, knowledge training, by implementing training schools. We will have 3 training schools, and also we will have hands-on project-based type of learning activities where the students will meet and integrate the technology and will test in realistic scenarios. So this is the overview of the training program. We will end up with a grand challenge, and finally we want to show the results in a final conference. During the 3 years that the PhD students will be enrolled in the different PhD schools and will participate in the project, they will be subject to academic and non-academic courses. They will go to 2 or more secondments for each ESR. So basically every student will go and sit at the desk of an academic and non-academic institution, at least. In several cases, it could be more, so that they gain also transferable skills, so that this knowledge that they develop is not purely academic, but it can also be exploited by the industry straight away after they graduate and the project finishes. There are 15 organizations. Here it's the summary of the consortium partner. And once again, there are 7 universities, 3 RTOs, 2 SMEs, and 3 enterprises. We have, I think we map quite well the value chain in the inspection and maintenance domain. We have knowledge institution, we have RTOs, we have end users, drone developers, service providers, sensor developers, and so on. If you want to meet us, you can visit the website. You can get in contact with us on LinkedIn. On the website, you have there is a contact form that you can use to get in contact with us, and you can follow us on the social medias. And this ends my presentation. Thanks for listening.
Hello, Matteo. Well, thank you very much for presenting this project. Also, for if there is any student looking for PhD, they can go to the website. I think there are still open positions, no? So just in case, you can go to aerotrain.etn.eu and then you can see it. I don't know if there is any question about it, but I think this is a very interesting project that tries to generate the type of engineers, the future engineers that will be needed for developing new tools for inspection and maintenance. In this case, aerial tools, I would say. So well, thank you very much, Matteo. If you can stay for a few minutes in case people want to ask you something, you can use this question and answer. We're going to launch voting, so you can, it will be a couple of questions. The one is about type of organization, so you can fulfill it. It could be great. Okay. And so that's always interesting to know where you're coming from. So yeah, thank you very much about that. And then I think we can go to the, while people are finalizing the...
Noemi, un segundo, que me voy a salir del Zoom.
Yeah. 1 second. Okay. So basically, I think we can go to the last project. It will be presented by Annalie Ross. Annalie? Hello?
Yes, hello. I'm
It's
here.
Hasta las 2. ¿Me oyes ahora?
1 second, I think we have some.
No,
Okay. Probably I have to. 1 second. Okay. I hope it will be okay. I just muted. So, Annalise, thank you very much. You, our last speaker, but I think people, most of the people is still online, so that's great. Okay. So Annalise is going to present Robotics for EU. It's a project that is looking for boosting wider adoption of robotics in Europe. Also, one of the sector this project is looking at is inspection maintenance. So please, Annalise, the floor is yours, and thank you for coming.
Thank you very much. As I was introduced, I am Anneli Rosa, the coordinator of Robotics for EU project, which started in January this year, so that we are still a quite young project, but I think that we are progressing well, and I'm very glad to introduce our main activities to you. As mentioned, inspection and maintenance is one of our focus areas. So we are a consortium consisting of 7 organizations from 6 European countries. So as you can see from the map, the white countries are our consortium partners, and we cover with 6 countries still almost whole Europe, so from Portugal to Norway. So what is the aim of Robotics for EU project? So we are a coordination and support action. So we are here to support you and your main research and innovation activities. And according to the European Commission, as you know very well, there are 4 main areas where different projects are active. So these are healthcare, inspection and maintenance of infrastructure, agri-food, and agile production. And what we should do across those 4 focus areas is that we should make sure that robots are more and more used and adopted across Europe, and not only robots, but let's be more precise, these should be also AI-based robots that should be adopted more. And what European Commission wants to know is that what are the barriers that hinder the more widespread adoption of robots? So the core challenges that we are going to investigate are that whether all the non-technological aspects of robots may cause some concerns why robots are maybe not adopted that well by the citizens, or also by, let's say, people at workplaces. So we should be reducing the barriers that hinder the adoption of robots, also in inspection and maintenance of infrastructure. And importantly, as mentioned, we are working with non-technological aspects of robots, meaning safety, ethical, gender, legal, societal, and economic aspects. Of course, also privacy and cybersecurity. While listening to your presentations, of course, it's very clear that those so-called non-technological aspects are very often also part of this technological solution that you are developing. So how are we trying to achieve more widespread adoption of robots, considering all those non-technological aspects I just mentioned? So we implement a very holistic approach, meaning that we really try to engage the whole robotics community, including industry and researchers, of course, also citizens and policymakers. So we have activities in our project for all those stakeholders. So we are active in analyzing that what is the problem and whether this lack of awareness about non-technological aspects of robots is actually also something that hinders the adoption of robots or the market access of different robotic solutions. So we just had a very interesting analysis that we completed, more than 1,200 200 robotic stakeholders, including also citizens, replied. And 26% of respondents mentioned that they are actually from inspection and maintenance of infrastructure field. And interestingly, we did not see very big differences among those different focus areas, but the respondents really mentioned that in the inspection and maintenance of infrastructure, they see that safety and security at workplace is, of course, the priority, as well as responsibility and accountability is important. And a sector-specific concern, it was highlighted that that data issues are a concern, and they should be dealt proactively. So I think it's also related to many aspects that were discussed here today earlier, and also what was mentioned by the Aerocam project, that there is this competencies and human resource gap, and actually our project is trying to tackle this by awareness raising, knowledge transfer, different workshops, and activities that help to understand what kind of robots are actually there. So this was actually one of the findings of our survey, that there is lack of understanding that what kind of robots are there, and what are the future developments, and how we could use them. So to sum it up once again, so as first, we're trying to facilitate understanding on the topic across all the four stakeholder groups. And then secondly, we have different activities where we will bring together all the stakeholders so that they can collaborate, and we try to really organize workshops where we raise awareness about all the non-technological aspects across those four areas. And importantly, of course, we also will engage companies so that they can introduce the technologies that they have developed, and they can also co-create them with citizens. So I'm sure that if you have followed now the developments regarding Horizon Europe, actually next to the impact that is important in Horizon Europe, of course, it is important that innovations should reach the market, and we should always think that who are the users of our technologies, so that who are the citizens or professionals that who are going to use our technology. And the philosophical background is that we should really co-create also technology, and this is what we are trying to do. So we are offering a platform for companies and also for universities to co-create together with citizens the future robotic solutions, or also we offer a platform to scale technology together with the end users. And importantly, our partner LNE and Agnes de Laborde, who just had a speech about the Metrics project, is also involved to our Robotics for EU project. And under the leadership of LNE, we are going to develop a responsible robotics maturity assessment model. And of course, one may ask that what is responsible robotics, but we define it as robotics that considers, next to the technological challenges, also the non-technological challenges, as we call them. And we don't want to do it alone. So already next week, on July 9th, we are going to have, under the leadership of LNE, a debate to discuss together with all stakeholders that what are the greatest challenges in robotics currently, and how should this responsible robotics maturity assessment model look like? So how to assess the maturity of the non-technological aspects of robots. So how to understand whether the solution is let's say, ethical and compliant to all data and cybersecurity aspects. So I'm really excited about this event. So it is still possible to register for that. So please if you're interested, go to our website and you will find this information to join us on July 9th. And as I mentioned, we're going to organize workshops across 4 focus areas, including inspection and maintenance of infrastructure. So we have planned to organize 4 online workshops, and if possible, as last one, also a physical workshop, or let's say, let's be modern, a hybrid workshop in the coming year. So here I would be really happy to collaborate with all of you. So after listening all those interesting and inspiring presentations, it might happen that we will be contacting you to invite you as speakers and participants to discuss once more, and maybe from a different angle, focusing mostly on non-technological aspects of inspection and maintenance of infrastructure solutions. And of course, it was also mentioned today that interdisciplinary collaboration is important and is one of the key aspects. So this is definitely something that will be tackled. So starting from September this year, we are looking forward to collaborate with you. And here are the main 5 topics that we have identified so far, and where we would like to collaborate and also introduce your solutions, your technological solutions to the users. So to continue from here, we will be organizing citizen consultations. It also means that you can tell us about your technological solutions, and let's test and brainstorm together with the end users and citizens about them. Of course, inspection and maintenance of infrastructure is a rather specific field where we can say that it's more of a professional use of the technology, but still, if we go back to this competence of people and workers also to be able to work with new technologies, I think that this is an important point that that needs to be tackled. To continue the discussion about the maturity assessment model, Robotics for EU and specifically LNE, we are working very closely together with European Commission on standardization. So I think that it was also mentioned today here a couple of times that standardization, that maybe there are too many standards partially, or maybe at some places something is missing. So this would be also a point of collaboration where we would actually be happy to receive input from you to map the situation and also to provide this information to the European Commission. That what should be done. So this information is very much wanted. And last but not least, we will have under the leadership of Robotex, who is a huge organizer of huge international robotics competitions, also a virtual exhibition where we would like to showcase robots and technologies that are currently available. So that we would like to promote technologies that are currently there, so that people would know that actually robots will make the life easier, safer, and so on. And this is not something that is threatening the jobs and so on. So this is also something where we would actually be happy to receive your input and just contact us and let us know that what interesting you have to offer. And that's it. Thank you very much for this opportunity.
Well, Annali, thank you very much for presenting this Robotics for EU project. I think there is one short question, at least. So they would like to clarify if the debate on July 9th is, I guess, is Central Time at summer, no? Central European Summer Time, no? I guess.
Yes,
This
yes.
is just a small typo. Okay.
Yes, it's
so
at 9. Yes, that's correct. It's Central European summertime. Yeah.
Okay. No, I understand this quite clear, but just in case it's important to clarify it.
It's
Okay.
always important to clarify this kind of thing. So
Yes. Yeah. Okay, so I think we are coming to the end. I don't know if someone would like to ask a little one more question about Robotics for You project. Anyway, in the meantime, I'm going to initiate the voting for the second question, which is how you like it, the workshop. Okay. Well, while you are voting, I think it was. I mean, we are going to finalize a little bit on time. Thanks, Annalie, for presenting, for the participating, and we're concluded this very fascinating workshop. Okay. Yes. So, I said before, we had 15 different projects. I think it was a very good overview of what is happening in Europe, okay, in the inspection and maintenance, applying robotics and artificial intelligence technologies. I hope everybody like it. As I would say that, like as conclusion, no, I think that it's important to have this kind of events that we can know much better each other. The different project leaders, so we can promote the collaboration and share best practices. So I think it could be a good idea probably by next year to organize maybe it could be even a physical workshop, but I think it could be interesting to organize something in relation to lessons learned. No, what are the projects? Not only presenting the project, but also maybe with a little bit more time. What are the lessons learned? And also, I think that as it was just mentioned, standardization could be also another topic that maybe we can learn from each other. We can try to work together because there is a lot of experience here in these projects that we can apply in order to standardize. So I hope in general that you like it. I really would like to thank to all the speakers, especially to fit into the 15 minutes. It was a really packed agenda and we were actually frightened to end at 4 o'clock, but finally we are going to end even a little bit earlier. And of course, I would like to also thank to the RIMA project, the RIMA Innovation Hub, and also the topic group of aerial robotics and inspection and maintenance topic group for their collaboration, the support in the from Robotics from this workshop. Basically, I think that was it for today. Hope you really enjoyed. Please go to the different web pages of the projects if you want to share more information. You want to keep updated, you can also, most of the projects, they have some kind of user group or some kind of list so you can get updated, or you can follow. I think every project has a Twitter account or LinkedIn account, so you can follow them. So it was a real pleasure to have all of you here in this workshop, and I hope you have very nice day, and we will keep in touch. Thank you very much, everybody.